Hi everybody. Welcome. Very good evening. Ajay, very good evening. Nani. Welcome to this amazing session, which is going to be a game changer in your preparation, people. Let me know if you can see me and hear me clearly, absolutely clearly. Am I perfectly visible and audible to each one of you? I want a quick good to go because today the chapter that we are targeting is none other than differential equations, one of the highest weightage topics, which is primarily important from your JEE Main point of view. Why? Because you get around 2 questions, 1 to 2 questions from here for sure. And because this chapter is used in cracking questions of other chapters as well, that is why this chapter becomes even more important. And I can say around 8 to 12 marks is the weightage of this chapter in your JEE Main exam. Tell me if I am perfectly visible and audible. Everybody, quickly tell me. All set? I am doing great. I am doing awesome. Am I perfectly visible, audible, people? Tell me quickly. All righty. Can I get started? It's differential equations on the plate today. Quickly share the session with all your friends across your groups, across platforms. Invite them here because today, what exactly is in store for you? Today, I want you all to sit tightly throughout the session with your pens and notebooks and with all your attention, all your focus, all your energy, all your headspace. I don't want you to be even 1% distracted because today's session is going to be heavy, but today's session is going to be 100% guarantee that you are going to earn those 8 marks which are going to come from the questions that will come from differential equations in your paper. That is a guarantee. But in order to ensure that that guarantee claim is held true, I want you to focus throughout the session, 100% focus on the session. Because today I'll be sharing with you plethora of questions. You know, as a matter of fact, that differential equations is a chapter which is full of questions. Full of questions. And it is the questions which give major struggle to the students. I don't want my students to struggle in differential equations. We have seen in 2020 and 2021, the level of questions of differential equations was pretty low in the JEE Main exam. But the moment 2022 came, 2023 came, the level of differential equations literally went up. And that is why we have to be 100% prepared with whatever type of question that comes in the paper from differential equations. And that is why today I have all varieties of questions, be it mains level, advanced level, new questions, each and everything. I will be making you rack your brain from start to finish. I will be making you brainstorm from every direction. I will be making you go heavy on the effort. So are you ready to put in your heart and soul, put in all your effort, put in all your energy in today's class? Are you ready? Yes? Yes, we will cover all the methods, be it variable separable, reducible to variable separable, homogeneous, reducible to homogeneous, linear, reducible to linear. And of course, we have exact differential equations as well, or the exact method, or the partial differential method. Everything is going to be covered in today's lecture with the help of tons and tons of beautiful, good quality, rich question bank. So today's session is going to give you a very fantastic, a beautiful and a very voluminous question bank with you. So please grab a notebook which has a lot of pages left because I want you to write all the questions, solve all the questions with me, understand every step, every approach. When does a question demand what approach? When a question looks like this, what do we actually do? How does it convey to us that, okay, I am a variable separable type, okay, I am a homogeneous type, okay, I am a LDE type, okay, I am an exact type. How does it convey to us? How do we interpret the language of that question? Everything is going to be supremely clear. So without any further delay, I am going to get started. Is everybody set? I'm going to get started. Yes, Devang, this is going to be a 100% question practice session because as it is in differential equations, you don't have much theory. The theory only comprises of a certain pattern of a question which has to be solved a certain way. That I will explain. That theory I will 100% explain. There is no theory because when it comes to formation of differential equations, that has been removed from your syllabus. And I don't want you to invest your time in formation of differential equations because that literally is not asked in the exam. There are many concepts or topics which are in your deleted syllabus, but questions from there are asked in the exam. Formation of differential equations is not at all important. So we are not going to waste our time on the topics or on the subtopics or on the concepts from where we are not at all going to get questions. All right. All right. Ajay, it's going to be around 3 to 4 hour long session, 100%. So without any further delay, people, let's dive into the discussion. You already know what is a differential equation. It is an equation involving what? Dependent variable, independent variable, yes or no? Differential coefficients. Yes, and of course functions. How does a differential equation look like? You are already well versed with it. You have seen a lot of differential equations throughout the tenure of your preparation. Let's dive into the primary topic from where the questions are asked in the paper, which is the different types of differential equations and how do we actually solve them. Okay, we have variable separable form, reducible to variable separable form, then we have homogeneous form, then reducible to homogeneous form, then we have linear differential equations, then reducible to linear differential equations, which is also called the Bernoulli equation. And apart from that, we also have bache exact form or exact differential equation. This is something which came as a surprise in the 2022 paper. Literally, students were not prepared that we're going to get questions of exact differential equation form, but it came. And that is why from that point onwards, I am specifically emphasizing on the preparation of exact with my students. If there is a question which can be solved using exact approach, then of course you must know how to apply that approach. First of all, you must have the knowledge of exact, and then you must know how to apply exact. So all of this I'm going to be teaching you. Good evening, good evening, good evening. Without any further delay, people, let's get started. The first question that I want to discuss with you, under the very first method, which is variable separable or rather reducible to variable separable, be it variable separable or reducible to variable separable, let's discuss the content and then let's dive into the questions. First of all, you know, variable separable, as the name suggests, is when you can separate the variable and there is a differential coefficient in support of that. That's it. You then integrate. So if you have dy by dx equals y by x, you know what does this mean? Dy by y equals dx by x. We have separated the variable and the respective differential coefficient is sitting with it. Correct? Integrate, integrate. This is log y equals log x plus not c, but let's say log c. So y equals x into c. That's your answer. This is your curve. This is your curve. Y equals f of x is the curve, which is a solution of this differential equation, with c being the arbitrary constant. In order to compute the value of this constant, we will be given some initial value condition, which right now we are not given. I am just giving you a very basic, very basic example as to how does a variable separable differential equation look like. As the name suggests, you just need to separate the variables. But look here very carefully. Now, this is the theory part which I want you to very carefully look at. Dy by dx equals a function of a linear polynomial in x and y. Listen to me very carefully, people. F of ax plus by plus c. Where this is a linear polynomial. How do you crack such questions? Any idea? Tell me any idea? For example, I have dy by dx equals 4x plus y plus 1 whole square. Tell me. Is this cool? So my right hand side is obviously a square of a linear polynomial in x and y. A linear expression in x and y. Is differentiation required? Differentiation is required, yes. Differentiation is required. Integration is required. Of course it's required. Use substitution. What substitution? Which substitution? Which substitution? You are going to plug in 4x plus y plus 1, whatever is that linear part, linear expression, plug that equal to t. You will get 4 plus y dash is equal to dt by dx. Alright, y dash means this is dy by dx. So dy by dx turns out to be dt by dx minus 4 is equal to t square. Tell me, is this clear? You will get t square plus 4 on the right hand side. This will give you dt upon t square plus 4 equal to dx. Bingo, people, this has been separated variable wise. This has been separated variable wise. Now, That's it. Done. Bingo. Okay. This is what? X square plus a square. 1 upon x square plus a square. What's the integration? Tell me. 1 upon a tan inverse x upon a equal to x plus c. Clear? Absolutely clear. And of course, then you will plug in the value of t as 4x plus y plus 1 over here. Don't forget to plug in the value of t in terms of the original variables which were x and y. Okay? Shreyas, trust me, these last few days that are left right now, they're so important. They can actually prove to be game changer. If you put in your 200%, you don't waste even a single minute and you prepare intentionally and truthfully. Truthfully means whatever is your weak spot, please polish upon that. Whatever are your strengths, strengthen them even more so that in the exam you can play to your strengths. Please speak true to yourself. Speak true to yourself. Be very, very truthful with yourself. Do not waste your time on unnecessary things, distractions. Please stay away from all of that. If you are preparing honestly, heart is at the right place, intentions are at the right place, trust me, whatever is right now that you feel you can achieve, you are definitely going to surpass that. You are 100% going to surpass that. Don't think about the destination. Just think about today, which is my preparation day today. The time that I have today in my hands. What can I do today, right now? Just focus on that. And this you have to do every day till the exam arrives, and then exam's result is just going to be a consequence. It's a byproduct. Okay? Definitely enough, Vijay. Definitely enough. We're just getting started. This is going to blow your mind. This lecture is going to be very, very beneficial, highly fruitful. And the questions which I will discuss with you, these are not random questions. These are not, you can't take them lightly. Just can't take them lightly. Every question has been cherry picked and every question is being shared with you because we are preparing in an exam oriented fashion. So this much, if you prepare in differential equations, your chances of scoring 8 on 8 in differential equations are 100%. So let's go. Moving ahead to the next thing, which is this. Now this is very important, a very famous form. This is a very famous form, people. Before I jump onto the PYQs or onto the actual questions, I just want to discuss with you some forms. Like the previous form I shared with you, dy by dx equals some function of ax plus by plus c. Right? Similarly, this is a form where dy by dx is equal to line 1 upon line 2. So ratio of two lines. Dy by dx is equal to ratio of two lines. In fact, they are parallel lines. Can you decode that? Parallel lines. Can you decode that? Yes or no? See, we have x plus 2y plus 3 upon 3 common x plus 2y plus 1. Can you see this? These are parallel lines, bache. In such a situation, what do you do? In such a situation, what do you do when you have L1 upon L2, ratio of two lines, and those two lines are parallel? What do you do? You must know what do you do. X plus 2y here, x plus 2y here. Please take x plus 2y equal to t. Perfect substitution. What do you get? We are trying to convert an equation into variable separable. It is not directly a variable separable. Like the previous one, it was not directly a variable separable. But we are trying to understand what will be our perfect substitutions, which will convert them into variable separable. A perfect, beautiful, easy peasy, very simple to manage variable separable. So this will give me 1 plus 2 dy by dx equals dt by dx. Okay. So dy by dx becomes what? This will be dt by dx minus 1 and upon 2. Yes? Equal to, this will be what? T plus 3 upon 3t plus 1. You can send the 2 over there, so you will get this, and you can send the plus 1 also there. That's it, people. That's it. This is dt by dx. You can clearly see the entire equation now is a differential equation and very easily variable separable. Very, very easily, this is a variable separable form. You can use your partial fraction method and you can solve this further. Very simple. Very good, Vijay. Very, very good. Awesome job done. Is this clear? Is this clear? For example, if the question comes like this, suppose it says dy by dx equals sine of x plus y. This is not directly a variable separable, bache. But this question is shouting out loud at the top of its voice that please take x plus y equal to t. When you take x plus y equal to t, you get 1 plus dy by dx equals dt by dx. Right? So this becomes dt by dx minus 1 equal to sine t. You can clearly see this is again a variable separable. No, this is a perfect variable separable form. T and x, separate everything about t, separate everything about x and then integrate. Easy peasy lemon squeezy. Is this clear? This is all about the theory of variable separable. Trust me. If it's a direct variable separable, great. If it's not a direct variable separable, it will either look like dy by dx equals some function of ax plus by plus c. We know what to do. Plug in that ax plus by plus c equal to t. Or it can be looking like what? Dy by dx equals ratio of two parallel lines. In that case, ax plus by, that portion we specifically plug in to be equal to t. That is the perfect substitution which converts our equation into variable separable. Or it can look like this. So basically, you have to understand that an equation might be directly variable separable or reducible to variable separable. Let's expose ourselves to some wonderful variety of questions which will even sharpen and polish your knowledge on how to crack questions based upon variable separable. So let's go, people. This is not a question which I will very honestly suggest you to attempt in the first round. This is not a question which I will very honestly recommend to attempt in the first round, in the first go. Generally, the questions of differential equations are lengthy, generally. And that is why you have to make sure that your question selection is top notch. You have to generally keep the questions of differential equations to be solved in the second round because they require time, they require a lot of focus, they require calculations, they require substitutions. They require you to be very precise with your arithmetic solving. Correct? So you can't be attempting questions of differential equations with stress. You have to be very much relaxed. You have to be very much in control of your thoughts and emotions and temperament, and then attack the questions of differential equations. Look at this one. Slope of tangent to a curve. Slope of tangent to a curve y equals yx. What is slope of tangent to a curve? Dy by dx. At any point x comma y is given to be this. Now you have to understand. Slope of tangent to the curve. Listen to me carefully. Slope of tangent to this curve at the point x comma y is given to be this. So directly they are not saying dy by dx equal to this, but this is what it represents. Dy by dx at the point x comma y will also be dy by dx. This is equal to 2e to the power 2x minus 6. If c is the curve which passes through this point and this point, then e to the power alpha equal to what? Very beautiful question. Very, very beautiful question. Tell me. Quickly tell me. How will you approach? This is directly not at all looking like variable separable. Is it? Is it? Jaldi batao. Is it looking like variable separable? Thank you so much, Aditya. Thank you so much. Keep putting in the effort and keep soaring higher and higher. Of course, it's variable separable. 110% it's variable separable. Everything about y on the left, everything about x on the right. It is variable separable directly. This is a direct variable separable form. Very good, Vijay. What substitution you think I should use? I can directly go ahead and integrate. But what substitution will I use? Anybody? Any idea? What is the substitution? The idea is very true. What you are saying is very right that ma'am use substitution. But what substitution? Which substitution? Come on, come on, come on, come on. Rack your brain, rack your brain, rack your brain. Hi, thank you so much. Super great to hear from all of you. No, Vijay, let me try doing that as well. E to the power 2x you're saying take as t. I am saying let's take e to the power x as t. Why? I'll just tell you. This will give me e to the power x dx equals dt, correct? This will give me y equals 2 times e to the power 2x. E to the power 2x means t square minus 6 upon t plus 9 upon 2 plus 9 upon t square, and this is dx is e to the power x dt and e to the power x is t, so t dt. Is this clear? Yes, correct. Correct. That's correct. Is this cool? All right. Next what? Now that you've reached here, let's simplify the right hand side. Left hand side to chalo is okay. Why? 2t cube minus 6 plus 9t. Very careful. Okay. And there is 2t square plus 9. Okay. Upon t and then upon t square. How will you resolve? Tell me quickly, tell me. Huh? You will have something like t square upon t, no, when you will simplify. And moreover, you have t dt. Tell me. Quickly tell me. Will you have this? You just have to solve. Bache, you just, oh, where is it? Yeah, here. Just have to solve 2t cube minus 6 plus 9t whole upon t. You can solve it here only. Let's solve it here only. So 2t cube minus 6 plus 9t, and this is whole upon t. Okay, and this is 2t square plus 9. 2t square plus 9 whole upon t square into t dt. I'm just asking you to resolve. Just asking you to resolve. Yes, you are clear, absolutely clear. All right, all right. So I guess people have been able to resolve. This will be dt. What next? What do you think is the next step? What do you think is the next step? Polynomial division. Okay, somebody is saying, ma'am, please separate. That's a correct approach. Look here. Please look here. Y equal to integration of, if you take out t common, what are you left with? This is plus 90. Let me write it here. Plus 90 and then minus 6. Okay. If I separate the t, I'll be left with 2t square plus 9 minus 6 whole upon again 2t square plus 9. Is this clear? Is this pretty evident to all of you? Is this pretty evident to all of you? E to the power x is t, dx is dt upon e to the power x. So this is upon t. Correct? So t upon t square. When eventually you will solve, here you are going to get t square upon t into 1 upon t dt. T cancels out. You're left with just 1 dt. That is why there is no t here when you are moving to the next step. Is this clear? Hi Sasha. I hope this is clear. How t got vanished? This t square and this t. Everything is vanished. Everything is together getting cancelled. You're just left with whatever is left behind. Correct? Okay. Now what? Y equals integration of separate. You will be left with what? You will be left with what? T dt minus integration 6 1 upon 2t square plus 9 dt. Yes or no? Yes or no? Very good. This will give you t square by 2 minus 6. What is this? Upon 2, 2 common, t square plus 9 by 2. So 3 by root 2 whole square. 3 by root 2 whole square dt. 6 upon 2 is simply 3. This much is cool? Is this much cool? Perfect. Please keep telling me if it's cool. Every step you have to absorb, digest, let it sink in. And that is why I want you to keep solving with me. Please solve with me, otherwise you'll be lost in between the question and then there is no coming back. Okay, and that reduces, that just lowers down your motivation, which I don't want for any kid in my class. Okay, fine then. Y equal to t square by 2 minus 3 times 1 upon x square plus a square is 1 upon a. 1 upon 3 by root 2, which is root 2 by 3. So root 2 by 3 tan inverse t upon 3 by root 2. T upon 3 by root 2 plus c. So 3 cancels out. Y is t square by 2 minus root 2 times tan inverse of root 2 t by 3 plus c. Tell me, is this hashtag HDCC? Yes or no? Hashtag HDCC, plug in the value of t back to be e to the power x. So y equal to e to the power 2x upon 2 minus root 2 times tan inverse of root 2 e to the power x upon 3 plus c. Guys, this is your final curve. Y is a function of x. Can you see this? This is your final curve. Vijay, Sasha, Jesse, everybody please see. This is your final curve. Y of x. This is your final curve. Yes or no? Perfect. Till here, I guess there is absolutely no problem. Let's move ahead now. Now I want to compute. Till here, everything clear? Perfect. Okay. Now I want to compute the value of this unknown, which is the arbitrary constant c. For that, I'm going to use this fact. The curve passes through 0, half plus pi by 2 root 2. So 0, half plus pi by 2 root 2. This is the point which lies on the curve. Can you see this? This point is lying on the curve. This point is lying on the curve. Huh? This point is lying on the curve. So I will plug in x as 0 and y as this value. So x as 0, y as this value. 1 by 2 plus pi by 2 root 2. 1 by 2 plus pi by 2 root 2. This is y when x is 0. E to the power 0 is 1, so you get 1 by 2. Alrighty, minus root 2 times. Be very careful while substituting. This is where major mistakes are committed. Root 2 into e to the power 0 will give you 1, so root 2 by 3 and plus c. This 1 by 2, this 1 by 2 cancels out. What is the value of c? C is pi by 2 root 2 plus root 2 times tan inverse root 2 by 3. Tell me, is this clear or not? Is this clear? So your final curve looks like what? Final curve looks like e to the power 2x by 2 minus root 2 times tan inverse root 2 e to the power x by 3, alright, plus c. C is pi by 2 root 2 plus root 2 times tan inverse of root 2 by 3. Everybody please tell me, is this clear? I am not spoon feeding you. I am not going to bring in very low hanging fruits type of questions which are going to get cracked like this, because those type of questions are not coming in JEE Main anymore, especially from DE, which is differential equations. So don't expect from me to give you very simple, very easy massaging your ego type of questions. No, I'm not here to do that. I'm here to actually teach you how to increase your stamina, how to build up that strength of your brain and of your solving capacity, so that you are able to crack these questions, stay with these questions, sustain solving in these questions. Okay, they're going to require patience, they're going to require stamina. Now that I have my final curve, guys, this is your final curve. This is your final curve. What do you need now? This curve is also passing through alpha, half e to the power 2 alpha. So alpha, 1 by 2 e to the power 2 alpha. This point also lies here. Also lies here, right? So plug in the value. Plug in the value. Y of alpha is 1 by 2 e to the power 2 alpha. This is e to the power 2 alpha upon 2. This obviously gets cancelled out. Minus root 2 times tan inverse of root 2 e to the power alpha upon 3 plus pi by 2 root 2 plus root 2 times tan inverse of root 2 by 3. This much part is completely constant, independent of alpha. This C part. Remember? Remember or no? Remember? So this minus part I'm going to send to the other side of the equality sign. Root 2 times tan inverse of root 2 e to the power alpha by 3 is equal to pi by 2 root 2. Now this is very simple. The question has almost come to an end. plus root 2 times tan inverse root 2 by 3. Now this root 2, let's bring it here. This root 2, let's bring it here. So this to chalo gets cancelled out. 2 into root 2 gives you 4. Pi by 4 bache is tan inverse 1. No. So if here you have tan inverse root 2 by 3, here you have tan inverse 1. On the right hand side, you can apply the formula for tan inverse A plus tan inverse B, which is tan inverse of A plus B upon 1 minus AB. Yes or no? So tan inverse root 2 e to the power alpha by 3 is equal to tan inverse of A plus B. 1 plus root 2 by 3, 1 minus root 2 by 3. Obviously, I am going to cancel the tan inverse. You're left with root 2 by 3 e to the power alpha is equal to 1 plus root 2 by 3 upon 1 minus root 2 by 3. Please tell me how, what are you saying? Tell me how we should use the t for substitution, you're saying? E to the power 2x can be chosen as t, but you just saw choosing e to the power x as t was more beneficial. Yes or no? Yes or no? Please tell me. This is 3 plus root 2 upon 3 minus root 2. All of this multiplied by 3 by root 2 is e to the power alpha. This is your final answer for question number 1. Is this clear? Pretty lengthy question, but trust me, please tell me, very honestly tell me, did you find it conceptually difficult question, or did you just find it a lengthy question? Because right in the beginning, when you wrote the differential equation, you were able to decode it's a direct variable separable equation. Direct variable separable equation. Yes? Direct variable separable. Correct? The moment you know it's a variable separable, now all you need is the technique of indefinite integration. Yes, so indefinite integration has to be strong when it comes to cracking questions like these, because there you have very much used the substitutions. Right? Once you substitute, you come here. You can very easily see there is a t square plus 2t square plus 9 above, 2t square plus 9 below. Cancel that out, simplify your integral. Here it's very basic, 1 upon x square plus a square form. Very easy. Once you have the curve which is sitting inside the blue bubble, you are chasing the value of c. And how do you get c? By plugging in the initial value condition, which is 0, half plus pi by 2 root 2. Once you do that, you get the value of c, plug it back. Now another point is alpha, e to the power 2 alpha by 2, plug in that and you get e to the power alpha's value. It's clear? Is this question hashtag HDCC everybody? Hashtag HDCC everybody. High definition crystal clear. Tell me. Tell me quickly. Is it clear? Yes, can I move to the next question? Is this absolutely clear? Questions like these are very heavily asked in the paper. So please make sure every bit of what I've done to solve the question is crystal clear in your head. Moving on to the next one. This is again a JEE Main PYQ. Y equals y1x, y equals y2x are two distinct solutions of the same differential equation with y1 of 0 equal to 0, y2 of 0 equal to 1. Then the number of points of intersection of y1 and y2 is what? What does this mean? What does the language of the question mean? There is one differential equation. Understand the meaning now, please. Listen to me carefully. There is a differential equation. You will solve it. You will get the curve in terms of plus c. You will get the curve with an arbitrary constant written. Once you will compute the value of that arbitrary constant, keeping in mind that the curve is passing through 0, 0. The curve passing through 0, 0 will come out to be your y1 curve. In that same equation, when you make the curve pass through 0, 1, as a result, the curve that you get will be the y2 curve. That's how both these curves are solution to the same differential equation. Because we are getting two different values of c for which these two curves are arising. And then we want the number of points of intersection of the two curves, which is a basic geometry part, basic part. Correct? Can I get started? How do you think you will solve this? How do you think you will solve this? dy by dx equal to x plus y. I want somebody to tell me the approach. Very good. I'm so happy. I'm so glad. Vijay, Roshan, You are on fire. You are nailing it in today's lecture. That much I can say. He's saying, ma'am, please take x plus y equal to t. I just gave you the example of dy by dx equals sine of x plus y. Or dy by dx equals a function of a linear expression in x and y. Always take that linear expression to be equal to t, guys. I've already shared this with you in the theory part of variable separable. Correct? Okay. Let's take this as t. You will get 1 plus dy by dx equals dt by dx. Correct? So dt by dx or dy by dx becomes equal to dt by dx minus 1 equal to t. Write it as t plus 1. So dt upon t plus 1 is equal to dx. Perfect variable separable. Easy peasy lemon squeezy now. Very good. And now you just have to integrate. Now you just have to integrate. You will get log of mod of t plus 1 equals x plus c. What next? What next? Quickly tell me. T, plug it back as x plus y. So your answer is log of x plus y plus 1 is equal to x plus c. This is your curve, bache, which I was talking about. This is the generic expression of your curve in terms of this arbitrary constant c. Now we have to perform two exercises on this same equation. The first exercise is that the curve is passing through 0, 0. If 0, 0 lies on this curve, you get log 1, which is 0, equal to 0 plus c. That means c will come out to be 0. Yes, very good, very, very good. C will come out to be 0. So you will get what? Log of x plus y plus 1 is equal to x. This is your curve 1. This is your curve 1. Please tell me if it's understood. Or I can write it as x plus y plus 1 is e to the power x. Or simply you can write y as e to the power x minus 1. This is your curve 1. This is your y1 of x. Similarly, if you plug in 0, 1, the curve passing through 0, 1 will give you a different value of c. 0, 1, when x is 0, y is 1, you get log 2 is equal to c. The value of c is coming out to be log 2. So you are getting log of x plus y plus 1 is equal to x plus log 2. Please tell me, is this clear? Is this clear, yes or no? That means you can rewrite this as, this is log of e to the power x plus log 2. I can write x as log of e to the power x. Is this clear? I can rewrite x as log of e to the power x because everything is in terms of log, only x is in terms of not log. So I can very easily write it as log of e to the power x. Log m plus log n is log of m into n. So you are getting x plus y plus 1 is equal to 2 times e to the power x. Yes ma'am, no ma'am? See, this is always positive now. So this also has to be positive only. I am able to remove mod, that's why. So y is coming out to be 2 e to the power x minus 1. But this y is actually your y2x. How many of you all have understood the meaning of y1x and y2x being solution of the same differential equation? How many of you all have understood the meaning of both y1 and y2 being solution of the same differential equation? You've understood? You've understood? Very nicely. Clear? Now you want points of intersection of both these curves. Very good. When you say you want point of intersection of two curves, that means you want to understand where do these two curves intersect. That means where do both these curves give the same y value for a certain x. So what will I do? Same y value for a certain x. Let's say for some x, y1x and y2x are equal. Let's say x is that quantity for which y1x and y2x are equal. So if y1x and y2x are equal, let's equate the right hand sides. E to the power x minus 1 is equal to 2 times e to the power x minus 1. This gets cancelled out. You are left with what? 2 times e to the power x minus e to the power x is 0. Anybody who's got the answer? I'm very excited. E to the power x is 0. No matter what value of x you take, bache, the graph of e to the power x always looks like this, isn't it? No matter what value of x you take, exponential function is always strictly positive. Yes ma'am, no ma'am? e to the power x is always positive for every real value of x. There is no real value of x for which e to the power x is 0. That means this has no solution. Did you understand? The number of points of intersection of both these curves is actually a big fat 0. This is actually a big fat 0. Option A is correct. Is this clear? Is this clear? Yes? Perfect? Perfecto? Yes or no? Perfect, right? Understood? So very conceptual question, very nice question. There was a meaning to the fact that two curves are solution to the same differential equation, because corresponding to two different initial value conditions, you were getting the definitions of both the curves, right? That's why. Yes. Okay, cool. That's why this question is really important, and the category of this question happens to be a star mark category. All right, let's go to a JEE advanced level question. People, everybody brace yourself quickly. Everybody brace yourself. A is the right answer for this question. This is a JEE Advanced 2017 PYQ. Please make sure that you are reading it correctly, analyzing it correctly, and you have to tell me the approach to crack it. This was asked in Advanced 2017, and when the kids saw it, when the students actually saw it, they froze. They literally froze. They were like, oh my God, what is this? And you know, when I think this is a psychology, this is a psychological problem, that whenever we see that a question has appeared in advanced exam, it somehow, our mind says it's inaccessible. It's beyond our doable zone, 100%. That's what mind says. But we are more powerful than the mind, right? Let me tell you, this question, even if this was asked in advanced exam, this is very easy to crack. One perfect substitution you need, and this question will be solved in a jiffy. If I tell you that substitution, you will be shocked that such an easy question was asked in advanced. Don't judge a book by its cover. Have you read that statement? Don't judge a book by its cover. Don't judge this question by its covering. It's very simple. It's very simple, and that's why it's a highly potential JEE Main question. Tell me. Take right hand side as T, entire right hand side. First you tell me what is the category, what is the type of differential equation. You can very easily see this much dy equals this much dx. So one thing is sure, it's very easily direct variable separable. I can write this as dy is equal to 1 upon 8 root x root over 9 plus root x, right? Into root over 4 plus root over 9 plus root x. All of this dx. Is this clear? What will you take as t? Harry Potter is saying under root 9 wala quantity, ma'am, you take as t. Anybody else? Just brainstorm upon the substitution. I want you to think of such a substitution. Whatever quantity you substitute, when you differentiate, the remaining quantity in the integral, inside the integral, the remaining quantity should vanish. That is the target. That is how easy this question is. Whatever portion you will take as t, whatever portion you will take as t or t square, whatever is your idea, because there are square roots involved, whatever portion you substitute, when you differentiate, the remaining portion in the integral should completely vanish. Go, went, gone. Bye, bye. Nowhere to be seen. Is there such a substitution possible? That is the magic of this question. If you take the right quantity for substitution, when you differentiate, everything is going to just vanish. Everything is going to just vanish. Tell me, which part do you think? 4 plus, very good, Vijay. I am so impressed. But this is the part which is actually going to help us. A little bit of foreseeing is required. A little bit of having long-sightedness is required, because if you take under root of 4 plus root over 9 plus root x as t, just keep looking at the magic. I am not doing anything. You differentiate 1 upon 2 times root over 4 plus root over 9 plus root over x into differentiation of quantity sitting inside the square root. Differentiation of 4 is 0. You get 1 upon 2 times root over 9 plus root x into 1 upon 2 root x dx equals dt. Please check this. And now when you simplify this, you are getting 2 into 2, 4 into 2, 8. So you are getting 1 upon 8 and then there is root x, alright. Then there is, then there is a root over 9 plus root x. And also there is root over 4 plus root over 9 plus root x. Correct? This much dx is equal to dt. Very good. Did you understand? Yes or no? So now what is your integral on the right hand side? Very simple. Very, very simple. Quickly see. This much part is t. So 1 upon t. Alright. Dx upon this quantity. Dx upon which quantity? This quantity is dt into t. Dx upon this quantity is dt into t. Tt cancels out. Tt cancels out. Here you had dy. So you are just left with integral dy equals integral dt. This is so easy. You should have a big smile on your face. Your teeth should touch your ears. Such a big smile. Such a big smile. Wide smile. This is the magic of substitution. The moment you realize it's a variable separable differential equation, perfect. Everything related to x on the right hand side, everything related to y on the left hand side, perfect. We have separated. Now it's time to integrate. Very, very obvious step was to substitute something. And this required some amount of training, some amount of foreseeing, some amount of mental math was required for you to decide as to which quantity will be apt for substitution. Which quantity will be apt? 4 plus root over 4 plus root over 9 plus root x. This quantity was apt for substitution, the bubble quantity. The quantity sitting inside the bubble was apt for substitution. Why? Because on differentiating it, the remaining part vanished. Go, went, gone, bye-bye. Correct? I hope you've marked this question for review because this question definitely calls for a comeback. Yes or no? Alrighty, J Advanced 2017 question. Quickly, let's crack it. Y equals t plus c. Please tell me if there is any problem, anyone? Yes? This implies y equals, what was t? T was this, root over 4 plus root over 9 plus root x plus c. This is your curve, but now it says 0 comma root 7. 0 comma root 7 is the point lying on this curve. So you will get root 7. Y is root 7 when x is 0. So root 9 plus 0 is root 9, which is 3. 3 plus 4 is 13. So root 13 plus c. Root 9 is 3. 3 plus 4 is 7. Not root 13, 7. This cancels out. You're getting c equals 0. So simply you have y of x equals root over 4 plus root over 9 plus root x. Please check. Okay. Conic sections I feel is a struggle area for you. Then don't worry. Please don't worry. Okay, you want y of 256. Tell me y of 256. Bache, what is this? 4 plus root over 9 plus root over 256 is 16. 16 plus 9 is 25. Its square root is 5. 4 plus 5 is 9. Root 9, which is 3. 3 is your answer. Now it's very simple. 3 is your answer. Option A is absolutely correct. Is this question clear? Yes or no? Yes, it was an advanced question, 100%. But you can very, very easily, nicely and honestly comment on it that, okay, ma'am, even if this was an advanced level question, I believe the potential of this question is that of JEE Main. It holds great chance to land in your JEE Main exam. This question or any of the similar type. The only place where it will give you major struggle is what to substitute. So I hope this question has given you a great practice of that. Alright, hashtag HDCC everybody. Let's go to the next one. Advanced 2018. Wonderful question again, and this is going to expose you to a new variety, which again is very important from mains perspective, and this requires a level of brainstorming. This requires you to polish your logic. This requires you to approach the question from a fresh perspective. This requires you to Attack the question with a non-tired mind. If your mind is tired, if you're stressed, if you're exhausted, questions like these, which are so easy to crack, can become a big hurdle. They can look like a Herculean task, but it's not. Trust me, it's not. It's not a Herculean task. It's very simple. It's a cakewalk. How will you crack this question? Tell me. F from R to R is a differentiable function with f of 0 equals 0. Initial value condition is given to us. The curve f satisfies this differential equation. What is the value of limit x tends to minus infinity f of x? First of all, I need to compute f of x. If I don't have f, I can't compute limit x tends to minus infinity of f. And what is f? F is the solution of this differential equation. One of the curve, which is solution of this differential equation passing through 0, 0, that is passing through origin. So let's solve this differential equation. You have dy by dx equals 2 plus 5y and 5y minus 2. This is like 5y plus 2, 5y minus 2. A plus b into a minus b is a square minus b square. So 25y square minus 4. Very clearly, very straight away, what is this? Variable separable. Dy upon 25y square minus 4 equal to dx. No, Vijay. No need for that substitution because you can straight away integrate. No. Yes or no? You can straight away integrate. No. 1 upon 5y whole square minus 2 square. Yes or no? Can you tell me the formula? Can you tell me the formula? 1 upon x square minus a square. Can you tell me the formula? Can you tell me the formula? Huh? 1 upon x square minus a square. What is the formula? What is the formula? Log of x minus a upon x plus a plus c. Do you remember the formula? Guys, these formulas are your true saviors. If you don't remember them, you have to write them down in the formula sheet. I have just released a YT short. How many of you all watched it? Just released a YT short, which is telling about the 5 time savior or your true savior hacks, which can help you in these last few days to really ace your math paper in JEE Main. And one of the hacks is to prepare formula sheet. Please prepare formula sheet, write all the formulas. Okay, cool. You know it, but you can't type it. That is cool. That is cool. So, x square minus a square, you can write this as, take 25 out common, you'll be left with y square minus 4 by 25, which is 2 by 5 whole square. Now it resembles our standard format 1 upon x square minus a square. So, 1 upon 25 as it is. Right? 1 upon 25 as it is, 1 upon x square minus a square. This is what? Log of x minus a. So, y minus 2 by 5 upon y plus 2 by 5. And then there is, 1 second, what is there? Is also there. What is also there? This much, that's it, equal to x plus c. So, you can instead bring this 25 on the right hand side. You can write this as 25x plus 25c is nothing but c. Is this clear? 1 by 2a is also there. Correct. Absolutely correct. When you write 1 by 2a, is that sorted? 1 by 2a is sorted. Please tell me. Is 1 by 2a part sorted? If I apply here 1 by 2a, what is a? 2 by 5. 4 by 5, which means 5 by 4. Is this clear? But the point is why I'm not interested in this constant, because this constant 5 by 4, this constant will go on the right hand side and it will not actually give me anything. It will actually not contribute anything in my answer. 1 upon 2a, 2 into 2 by 5. So 4 by 5, which gives you 5 by 4. 5 by 4 will go on the right hand side, log of y minus 2 by 5 upon y plus 2 by 5 equal to 4 into 25x upon 5 plus again a c. Let's say this is C1 and this is C. C into constant will give you. Cool. That is fine. That is fine. Now tell me. This is 20x plus C. Alrighty. Is this cool? Is everything cool till here? Clear till here? Now what are you getting? You are getting log of y minus 2 by 5 upon y plus 2 by 5 equal to 20x plus C. Alright. Now what is the biggest mistake which students commit? In such a question, that's fine Vijay, that's fine. The biggest mistake which students commit is they plug in the value 0, 0 here. They plug in the value 0, 0 here, which is perfect step. When you plug in the value 0, 0 here, what is the value? Log 1 is 0, 20 into 0 is 0, C is 0. So this implies C is 0. If C is 0, your curve simply becomes y minus 2 by 5 upon y plus 2 by 5 log of this equal to 20x. Now the mistake which you are not supposed to commit is don't try to solve for y. Don't try to explicitly run behind what is my y equal to f of x. Don't do that. Y is sitting inside log like a rational expression. Don't try to solve for y. Why am I saying that? Because I just need limit of f as x approaches minus infinity. Here only, at this stage only, let x tend to minus infinity. The moment x tends to minus infinity, bache, what happens? As x approaches minus infinity, what happens? Please tell me. Limit x tends to minus infinity log of mod y minus 2 by 5 upon y plus 2 by 5. Alrighty, is equal to limit x tends to minus infinity of 20x. Now, this much part I know is nothing but minus infinity only. As x tends to minus infinity, 20x also tends to minus infinity. What about the left hand side? What about the left hand side? Log of something is tending to minus infinity as x tends to minus infinity. Remember the graph of log. This is log graph. This is your log. Log of something is tending to minus infinity. The right hand side is minus infinity. So log of whatever is tending to minus infinity. What can you comment about this whatever? Do you understand? Log of this quantity is tending to minus infinity. What can you comment on this quantity? When does log of something tend to or approach to minus infinity? Look at the graph. When does log of something approach to minus infinity? Yes, when this inside quantity approaches to 0. When the input approaches 0, your output of log approaches minus infinity. Right? So if log of this is approaching minus infinity, that means y minus 2 by 5 upon y plus 2 by 5 will approach to 0. That means without mod also this will approach to 0 only. Right? And something upon something can approach to 0 when? When the numerator approaches to 0. So y minus 2 by 5 approaches 0 or y approaches to 2 by 5. So as x tends to infinity, y tends to 2 by 5. As x tends to minus infinity, y tends to 2 by 5. So limit of y as x tends to minus infinity is 2 by 5. That's the final answer. 0, yes. No. See, the input for log cannot tend to minus infinity because log is only defined for strictly positive real values, strictly positive inputs. The input for log can never ever tend to minus infinity. Okay? It can only tend to plus infinity or it can tend to 0. Look at the graph, no? The graph of log doesn't exist on the left of the y-axis. Alright? Alright? Yes or no? Okie dokie, then we are through with variable separable, everybody. Give me a quick thumbs up if all the questions are crystal clear to you from variable separable. Of course, this is not the end of variable separable because every other form that we will study will be convertible to variable separable. Like a homogeneous form, linear differential form, exact form, not exactly exact form, but majorly questions of any other form in the beginning towards the end convert to variable separable. Right? Okay, so let's go to the next method, which is our homogeneous method, people. Let's get started. Understand, homogeneous differential equation. When do you say a differential equation is homogeneous? When it looks like dy by dx equals to f of x comma y upon g of x comma y. So f is a function of x and y, g is a function of x and y. So it's a what? It's a quotient of f and g, where f and g are homogeneous functions of x and y of same degree. So they both have to be homogeneous of the same degree. Homogeneous functions of x and y of the same degree. So x and y, the degree of x and y, the degree of x and y in f and g have to be same when you add all of them up. In that situation, what do? The moment you have declared an equation to be a homogeneous differential equation, what do? You plug in y equal to vx or tx or ux, then you substitute. After the substitution, you perform the differentiation, and bingo, your differential equation very, very easily gets converted to a variable separable equation. Your differential equation very easily gets converted to a variable separable equation. Yes, that is true. For example, look at this one. dy by dx equals x square plus y square upon xy. Now the numerator, every term is of degree 2. So the degree of the numerator polynomial is 2. Degree of denominator polynomial again is 2. This is x to the power 1, y to the power 1, 1 plus 1 is again 2. So definitely they both, numerator and denominator, are homogeneous functions of the same degree 2. Perfect. Perfecto. This is 100% a homogeneous differential equation. What do? You plug in y as vx, which implies dy by dx equals v plus x into dv by dx. Plug it back. V plus x into dv by dx equals x square. Y square is what? V square x square upon x into vx. So this will give you 1 plus v square upon v, because x square gets cancelled out. You will have x dv by dx equals 1 plus v square upon v minus v. This will give you 1 plus v square minus v square upon v. This will give you 1 by v. So v dv is equal to dx upon x. Isn't this variable separable? Integral, integral. This is perfect variable separable form. That's how easy it is. The moment you decode it's a homogeneous differential equation, the next step, very obvious step, very obvious step is plug in y as vx or ux or tx, your choice, differentiate, substitute, resolve, and eventually you will get a variable separable form. Right in the end, substitute y as vx, or rather I should say substitute v as y by x. In the end, this is the substitution you have to follow, so that my entire answer, my entire curve, everything gets converted to my original variables x and y, and v is nowhere to be seen. Alrighty, is this cool? Now comes a very important part, which you might not understand when I share the theory with you, but you will 100% understand when I will share the questions based upon this with you. But let me still breeze you through the theory. Let's skim the theory of this. When you have dy by dx equal to L1 upon L2, where both L1 and L2 are parallel lines, in that situation I told you ax plus by part you substitute as t, and you very easily convert it to variable separable. But what if my dy by dx equals look like L1 upon L2, where L1 and L2 are not parallel? If L1 and L2 are bachche not parallel, what do? You perform a magical substitution. This is a magical substitution. You perform this magical substitution. You write small x as capital X plus P or capital X plus H, and small y as capital Y plus Q or capital Y plus K. Whatever is this constant P, Q, H, K, A, B, that is irrelevant. But you always try to translate things and shift things. Remember, in coordinate geometry we used to do this. Same translation or shifting we are doing here. Replace small x with capital X plus P, replace small y with capital Y plus Q. When you do that, obviously your d small x is same as d capital X, d small y is same as d capital Y. What do you get? You get this. You get this. This is how your new transformed differential equation starts looking like. And here, bache, what do? This much part and this much part equate to 0. Why? Because when both these brackets will vanish, you will be left with this much differential equation, which is 100% homogeneous. Okay, so this is how you convert an equation to homogeneous. But under the condition that both these brackets simultaneously become 0. When both these brackets become 0, you will get A1P plus B1Q equal to minus C1, A2P plus B2Q equal to minus C2. These are actually two equations in two unknowns, P and Q. Yes, so you can very easily solve them, get the values of P and Q. For those values of P and Q, both the brackets are 0. They have vanished. For those values of P and Q, which you will then substitute, both these brackets have vanished. And now what I'm left with is this differential equation, which is perfectly homogeneous, and I know how to solve it. So this was the drill. Actually, this was the drill to convert an equation which is not homogeneous into homogeneous. And specifically, what is the look of that original equation? dy by dx equal to L1 upon L2, ratio of two lines where both of them are not parallel, bache. They are not parallel. In that case, you have to substitute small x with capital X plus P, small y with capital Y plus Q. When you substitute, differentiate, you get a transformed differential equation, wherein the latter part in the numerator and denominator has to go to 0 simultaneously. When it does, then only you are left with a homogeneous differential equation which you solve. And in the end, hi Yash, in the end you plug in these values of P and Q which you had got by solving both these equations, these two equations. Both these equations. In the end, you will plug in the values of this P and Q and you will get your final answer. Okay? Making sense, everyone? As I told you, I'm just sharing the theory of this type of a differential equation with you. But when I share with you the question, that is when you will very nicely understand as well. Let's start. Let's start without any further delay, everybody. If the solution curve of the given differential equation, which passes through the point 1, 1 and intersects this line at the point alpha, root 3 alpha, then the value of log of root 3 alpha is equal to what? Please tell me. Hello, Mr. Rambo. Tell me quickly. First of all, I want you to spend a few seconds decoding this. I want you to tell me, is this homogeneous or not? Is it possible to express this as an equation in y by x? If you're able to express the entire equation in y by x, then we can directly substitute y by x as t or y by x as v, which is equivalent to y equal to vx or y equal to tx, and then solve further like I explained you before. Tell me quickly. Quick. Is this homogeneous? Think carefully, okay? No need to hurry, no need to rush. Y square dx plus x square minus xy plus y square dy. Can you see? Every term involving x and y is of degree 2. Every term involving x and y is of degree 2. If you even wish to write it, like dy by dx, you will get y square. Is this visible? Is this color visible? Red. Y square dx is equals to minus of x square minus xy plus y square dy. So dy by dx is equal to y square upon minus of x square minus xy plus y square. Yes, absolutely correct. Absolutely correct. This is 100% homogeneous differential equation, everybody. Correct? So plug in y equal to vx. Right? So dy by dx. And this time you do it. Now moving ahead, you will remember only that dy equal to vx means dy by dx have to substitute with v plus x into dv by dx. This is something which you will very easily remember. You will be able to write in one shot only without solving again and again and again. So v plus x into dv by dx. Okay, so dy by dx, v plus x into dv by dx. Next is equal to minus y square upon x square minus xy plus y square. Is this simple or no? Is this simple or no? Quickly tell me. Is this simple or no? Is this simple or no? Y square, v square x square upon x square as it is minus x into vx plus y square is v square x square. So from numerator and denominator, v square cancels out, you're left with, not v square, x square cancels out, you're left with minus v square upon 1 minus v plus v square. So x into dv by dx will turn out to be minus v square, 1 minus v plus v square minus v. Simple dimple. This will give you minus v square minus v plus v square minus v cube upon 1 minus v plus v square. So minus v square plus v square cancels out, minus common, v cube plus v upon 1 minus v plus v square. This is now a variable separable equation because 1 plus v square minus v upon a minus of v plus v cube dv is equal to dx upon x. Perfect variable separable, guys. Integrate. Please tell me if it's clear. I have done nothing. My question was just out loud shouting that I am homogeneous. And I just used the algorithm which is used to crack homogeneous differential equations. Okay. So I can send this minus sign above also, minus here and plus here. Right? So I will be left with minus v square plus v minus 1 upon v common v square plus 1. Right? Dx equal to integral, no, dv equal to integral dx upon x. Is this clear till here? Very important question, people. Very important question. Quick. Now see, you have minus v square minus 1. Minus common v square plus 1 you can write. Minus common v square plus 1 you can write, and plus v as it is separately you are writing. Numerator, denominator, both of them have v square plus 1. So separate. You will get minus 1 upon v dv plus integral 1 upon v square plus 1 dv equal to integral dx upon x. Please check. Please check. Quick check. Yes. So minus log v. V is what? Y by x plus what? 1 upon x square plus a square is 1 upon a tan inverse x upon a. V upon 1. V means y by x equal to log x plus c. Yes or no? Clear till here? This is my answer to the curve. But this is passing through 1, 1. Can you see this? It's passing through 1, 1. Very important questions, people. Log 1 is 0. Okay. Tan 1 is pi by 4. Log 1 is again 0. C is pi by 4. Plug in the value of c as pi by 4. You will get minus log y by x. Then you have plus tan inverse again y by x equal to log x plus pi by 4. Yes or no? Yes or no? Correct? What do you need? This curve intersects the line y equal to root 3x at the point alpha comma root 3 alpha. So this is some curve C1. Let's say C1 is the curve. So this curve is intersecting the line. Let's say this is the line at the point. What is the line? Y equal to root 3x. At some point P it's intersecting. The coordinates of P are alpha comma root 3 alpha. That means this P point is lying on the curve also and lying on the line also. So I can say my alpha comma root 3 alpha, this is the coordinates of a point lying on my curve. Yes or no? So alpha comma root 3 alpha. So root 3 alpha upon alpha log root 3. Yes or no? Minus log root 3 plus tan inverse of again root 3 is pi by 3. Correct? Equal to log x, that is alpha, plus pi by 4. Please tell me. Tell me quickly. So you will get what? Log alpha plus log root 3. This I am sending there, this I am bringing here. So log alpha plus log root 3 is 60 minus 45, which is 15 degrees. 60 minus 45 is 15 degrees, which is actually pi by 12. Log m plus log n is log of m into n. Root 3 alpha is equal to pi by 12. That was what I was asked. What is log root 3 alpha? It is nothing but pi by 12. Pi by 12 is your final answer, everyone. Please tell me if it's clear. Pi by 12 sitting in option C is your final answer. Everybody, quickly tell me. Quick. Is every bit of this question clear? Very easy homogeneous differential equation, but questions from differential equations are lengthy. They do require you to perform a lot of calculations, a lot of substitutions, a lot of simultaneous solving, a lot of language decoding. If that much you are comfortable with, then these questions will not go unsolved by you. That is my promise. So why are we solving level up questions in today's class? I am not giving you very NCERT based questions. No, I am giving you literal level up questions. Why? Why? Because I want you to brainstorm. I want you to get exposure of all these rich variety of questions so that in the paper there is no surprise for you. You don't feel an unfamiliarity with the questions of differential equations. They should feel familiar to you. When a question feels familiar, your confidence boosts. That is a decision that you attack it in the first round or in the second round or in the third round, depending upon the length and the time it demands. But the moment you sense familiarity with a question, it gives a dopamine rush. It just gives a big boost to your good hormones. It makes you feel very confident, and of course that confidence, that feel good factor helps you attack other questions in a nice way as well. So increase familiarity with more and more good quality questions so that in the paper or in the mock test, whenever you sit for it, questions don't seem like a shock to you, like a surprise to you that, oh my God, what is this? I've never seen it before. This should not happen. And students, my students, that they will never face this for sure. They will never face this. Okay, I will make you solve all sorts of questions. Pi by 12 is the right answer for this question. Thank you. Let's go to this one. Again, very nice question, but here is a catch. This question will present in front of you a catch. This question will present in front of you a catch. Tell me, what is that catch? There's a very nice catch in this question. I want you to decode that catch. What do you think is it? dy by dx equals ax minus by plus a upon bx plus cy plus a. Again, it's very, very evident that it's a homogeneous differential equation. Yes or no? dy by dx equals ax minus by plus a upon bx plus cy plus a. 100% numerator and denominator both are of degree 1. Homogeneous functions of x and y, degree 1. Right? How will you solve this? There is a short trick. Tell me, Yash, what is the short trick? There are two approaches. See, read the question carefully. It says, this is your differential equation and this is representing a circle passing through 2, 5. So already I know that the solution of this equation is a circle. Till now, whatever questions we've solved, we just knew that the solution of this equation is some curve passing through a known point. We never knew what is the shape of that curve, trace of that curve, look of that curve, design of that curve. This time, this question is telling me what is that curve. It's a circle. It's a circle of what radius, I don't know, but it's a circle with center 2, 5. It's a circle with center 2, 5. I know it, and I can exploit this piece of information to make this question supremely easy for me, highly manageable for me. But how? But how? See, there are two ways. You can say, ma'am, method 1. Method 1 is that my differential equation looks like dy by dx equals line 1 upon line 2, where line 1 is not parallel to line 2. I have just shared that part of theory with you, where when you have such a situation of dy by dx equals L1 upon L2, where they both are not parallel, like in our current situation, in the current question, what do? You replace x with x plus h, you replace y with y plus k, and then transform your given differential equation and then convert into homogeneous and then solve. Very lengthy process. Now, if this would have been unavoidable, I would have done that. Definitely. But in this question, because I know the shape that traces the look of the final curve, which is a circle, I'm going to use method 2. Method 2, assume a circle and find dy by dx with respect to it. Lastly, compare. What do I mean? What do I mean? See, you are given dy by dx whose solution is a circle. I can backtrace this exact same flow. I can backtrace this. I'm going to start with a general circle, and I will differentiate it. I will differentiate it to get the dy by dx corresponding to it. That is what is going to be method 2. And whatever dy by dx comes, I will compare it with my given dy by dx, and from there I will get my unknowns or my variables or constants. Is this clear? This is a very smart approach. We are not going to use method 1. If you wish to, you can take it as homework. But trust me, when you know the shape of the curve, which is coming out as the solution of my differential equation, start with that curve. Start with the circle. Back differentiate it to get the dy by dx corresponding to it, the differential equation corresponding to it, and then compare it with the differential equation given in the question. They both have to be the same differential equation. No, I am saying let this circle that I am assuming is the circle which is the solution of my given differential equation. Then if I backtrace it and I differentiate and I compute the differential equation corresponding to this circle, it should match my differential equation given in the question, right? Very beautiful logic. So let's start with that. Can I start? Circle which is the solution, let's say it looks like x square plus y square plus 2gx plus 2fy plus c equal to 0. Please tell me. Cool, this is my circle. The differential equation corresponding to it should come out to be this, because my circle is a solution of this equation only. Okay, so let's compute the differential equation corresponding to it. I will get 2x plus 2y dy by dx plus 2g plus 2f dy by dx equal to 0. Okay, dy by dx, and you have 2y plus 2f equal to minus 2x minus 2g. 2 throughout cancels out. You are left with dy by dx equals minus x minus g upon y plus f. How many of you all agree? Yes, yes. If you know the general look of the curve which is coming out to be the solution, you can use this approach. Okay, this is my differential equation which I am getting corresponding to my circle. But corresponding to the same circle, the equation given in the question is the equation. That means both of them have to match. Dy by dx equals ax minus by plus a upon bx plus cy plus a. Compare. Just compare. Just compare. Nothing else. Just compare. Coefficient of x is a, here it's minus 1. Okay, coefficient of, okay, minus g is a. Minus g is the constant part, which is a is minus 1, which implies g is 1. Coefficient of y is c, so c is 1. F is the constant, f is actually a, which is minus 1. What about b? Tell me bx. From the denominator, coefficient of x is b. That means b is 0. And from the numerator, coefficient of y is minus b. On the left hand side, it's 0. So this is it. A, B, C, and G and F. Everything is sorted. Everything is sorted. Everything is sorted. That means now I can perfectly and precisely write the circle which is my solution. My circle, which is the solution, will now look like x square plus y square plus 2gx. G is 1. So plus 2x, f is minus 1, minus 2y, and c is 1 equal to 0. Any confusion till here? Please tell me, any confusion till here? Oh, this c is not that c. Okay, wait, 1 second. This cy, it is this c. I don't know what is this c. Let's say this is capital C, okay? Let's say this is capital C. This much I don't know. I have to understand this capital C part, I don't know. I know this C's value, which is 1. But I don't know what is the value of my capital C. No, that I don't know. And this is my solution. Now, what does the question say? Represents a circle passing through the point 2, oh, it's passing through the point 2, 5. I thought 2, 5 is the center. Okay, whatever. Just one piece of information was known to us. The circle is passing through the point 2, 5. So 2, 5 is obviously going to lie here. 2, 5, 4 plus 25 plus 4 minus 10 plus c is 0. Plus 4 plus 4, 8. 8 minus 10 minus 2. 25 minus 2 is 23. Can I say c is minus 23? Please check. Can I say capital C is minus 23? Because if that's the case, then my circle will look like x square plus y square plus 2x minus 2y minus 23 is 0. This is my solution. Okay, this is my circle. The shortest distance of this point from this circle. What is the center of this circle? Minus g comma minus f minus half of coefficient of x and minus half of coefficient of y. Tell me, minus 1 comma 1 is the center. So we have the circle with minus 1 comma 1 to be the center. 11 comma 6 is a point lying inside the circle, outside the circle, or on the circle. It's obviously lying outside the circle. You know, the shortest distance always occurs. The shortest distance always occurs along the normal. How many of you all know this? Very important piece of information. The shortest distance always occurs along the normal. So if I say 11, 6 is a point P, then P is closest to which point on the circle? P is closest to which point on the circle? Well, you draw a line passing through P and the center. You draw a line passing through P and the center. Right? This is a normal of the circle. Yes, and this is intersecting the circle at point Q. That means PQ is actually the shortest distance. This is what you need to find. P is closest to point Q on the circle, because this Q is sitting along the normal. Yes or no? How do you find QP or PQ? How do you find PQ? From this entire distance, which is D1, you subtract the radius. What is the radius? What is the radius? Under root G square plus F square minus C, which gives you 5. And what is the distance between the center and point P? It is under root of 11 minus 1 is 10 square, 6 minus 1 is 5 square, which is under root 125. Please tell me if this is what you are getting. Is this what you are getting? Oh, this is 11 plus 1. Okay. 144 and 25 is 169. 169 will give you 13. Okay. So 13 minus the radius. 13 minus 5 will give you 8. This is your shortest distance. Is this absolutely clear? Got it, ma'am? Is this absolutely clear? Guys, please subscribe to the channel if you have not done that yet. Sessions like these take a lot of effort to get prepared for you and from my side as well. And also because we are so close to the exam, even richer sessions. This is a very rich session, but I'm promising you even richer sessions are waiting in the queue to come and be discussed with you. So don't forget to subscribe to the channel and also hit the like button if you have not done that yet. That helps me understand that you are liking the session and it helps me understand that you were attending the session. It's a mark of your attendance. Alrighty, is this question clear? It's a very classic variety of question which is pretty different from the normal category of questions. And questions like these are a slippery area for students. Because here, if you adopt method 1, you will keep on solving with method 1 for ages and the answer will come, but it will come after a long time. That much lengthy approach we will not adopt provided we have a shorter approach, which is M2. So the solution, if you know, is a circle. Start with the circle, backtrace it, compute the differential equation corresponding to it and compare it with the given differential equation. From there, compute the value of the unknowns and bingo, you have your circle with you. Because the circle was passing through 2,5, from there I got the value of this unknown constant as well. Now that I have my actual proper full circle, then I can compute the center, the radius and then the very bacha concept, kiddo concept. That the shortest distance always lies along the normal. Use that, get the answer, bingo, the question is scrapped. Done and dusted. Done and dusted. All right. All right, 8 is the right answer. Okay. What is the doubt? Ask me right away. Ask me right away. Quick. What is it in? Yes, you can proceed. Some of the other piece of information will be given, which will make you realize that, okay, it's the parabola having vertex at origin or is it a shifted parabola? Accordingly, you can assume the equation. So don't think the question is going to be that random. Okay, it won't be that random. Okay, don't worry. Chalo, let's come to this question. Again, very important, very nice, pretty brainstorming, and through these questions that I'm sharing with you, my target is to expose you to as much variety as I can, to expose you with the different language of questions which can come from differential equations. So let's understand dy by dx. X dy by dx minus y is this. Y of 1 is 3. What is y of 2 equal to? Very straightforward question. No fancy piece of information given. So how will you crack this? First of all, try to decode what is the type of differential equation. What is this type? What is the type? Tell me quickly. What is the type? X dy by dx minus y equal to root over y square plus 16x square. It is homogeneous. It is 100% homogeneous. Everything you see is of degree 1. Under root of y square plus 16x square. It's under root of y square plus 16x square. Degree is 1 on the right hand side. Left hand side, x, y, degree is 1. This is homogeneous. This is homogeneous. So what will you do? Throughout divide by x, you will get dy by dx minus y by x equals what? Under root of y square plus 16x square upon x square. Divide by x means divide by under root x square. Same thing. So this will give you y by x whole square plus 16. Yes or no? Yes or no? I have deliberately converted my equation in terms of y by x. Why? Because now I can directly plug in y by x as u, or let's say v, which means I'm plugging y equals to vx. It's the same thing. If you don't convert your entire equation in terms of y by x, that's also fine. The moment you know it is homogeneous, just plug in y as x. Just plug in y as x. That will also do the purpose. So now you know what you have to do. dy by dx equals v plus x into dv by dx. Yes? Yes or no? So dy by dx minus v is x dv by dx. X dv by dx is equal to under root of v square plus 16. So you are getting dv upon root over v square plus 16 is equal to dx by x. Tell me. What is 1 upon under root of x square plus a square? 16 is nothing but 4 square. Tell me. What is 1 upon under root of x square plus a square's integration? Yes, log of x plus root over x square plus a square. Log of x plus root over x square plus a square is equal to log x plus, let's write log c. Let's write log c, right? So log of m, log m plus log n is log of m into n. Log cancels out, you're left with v plus root over v square plus 16 is equal to cx. Yes or no? Yes or no? This is what? This is y by x. This is what? This is under root of y square by x square plus 16. So you can write this as 16x square upon x square. So this is again upon x, right? So let's transfer this x on the right hand side. I am going to get y plus root over y square plus 16x square equal to cx square. Now this is my curve. Okay, this is my final curve, but this is passing through 1, 3. Oh, so plug in the value 3 plus root over 9 plus 16 equal to c into 1 square is 1. 9 plus 16, 5 plus 3, 8. So c is coming out to be 8. That means you have y plus root over y square plus 16x square equal to 8x square. This is my curve. I've got the curve. What is y of 2 equal to? What is y of 2 equal to? So y of 2 plus root over. When you say y of 2, what are you getting? X has to be plugged as 2. 2 square is 4. 16 into 4, 64 is equals to 4 into 8, 32. Tell me. Quick, quick, quick. What is y of 2 coming out to be? Very quick. What is y of 2 coming out to be? Okay, okay. Please check. I will not compute, you compute. What is y of 2 coming out to be? 2 square is 4, 8 into 4 is 32. Quick. Tell me. Answer, answer, answer. What are you getting? This is your final curve. All you have to do is plug in x as 2. Come on, come on, come on. Plug in x as 2. Won't you get, when you plug in x equal to 2 in this equation, you will get y plus root over y square plus 64 equal to 32. For what value of y will this equation get satisfied? For what value of y will this equation get satisfied? Don't get stressed. Don't get stressed. You can simplify it by bringing 32 on one or writing it like this, okay? Y square plus 64 equal to 32 minus y, squaring, cancelling out the y square, then computing y. That much you can do. But if you use your hit and trial as well, y will come out to be 15. Can you check that? Can you check that? As I told you, keep the square root part on one side, take everything else on the other side and square both sides. When you square both sides, the y square part will cut out and you will eventually end up getting y as 15. Very, very simple process, algebraic process. I think that much you can 100% compute. Yes, 100% compute. Is this question clear? Very straightforward, direct question of homogeneous. We have done nothing fancy in this question, right? Just very strong on the calculation part, nothing else. This question is not that much a struggle. Yes? Alrighty. Let's go to the next question. This is very nice. Just look at it. The order of this differential equation is 2. Can you see that? D square y by dx square plus dy by dx minus 6y equal to 0. Order is 2 and in our syllabus all we have is first order differential equations. But questions like these have popped up before and they will be popping up again and again. As I told you, in our syllabus we have first order differential equations. But these type of equations also have come in the past and they can come in the future as well, where the order is greater than 1. It's 2 over here. Look at the question. Y of x is given to you, alpha beta is not known to you, beta not equal to 2 is a solution of this differential equation satisfying dy by dx at 0 is equal to 5. What is y of 0 equal to? Now you have to be very much well versed with the language of this question. Till now we were getting y of 1 is 2, y of 0 is 3. Right now we have dy by dx of 0 is 5. Right now we are given this is the solution to my differential equation. So again, remember that circle question? If I know circle is the solution, I will write the general equation of the circle and I'll reverse engineering. I'll do reverse engineering. I will differentiate it to get the differential equation whose solution is that circle. Same process I will apply here. Because I need a second order equation, second order differential equation, and here you can see there are two unknown constants alpha and beta, which matches the fact as much is the order of the differential equation, same is the number of arbitrary constants present in the solution. So alpha and beta are two arbitrary constants present in my solution curve and my differential equation is of second order. So what I'll do is I'll start with the solution curve and I will do the reverse engineering. I will differentiate it 2 times and then I'll see what I'm getting. So let's start. Y of x is equal to lambda times e to the power 2x, not alpha beta, lambda beta. These are the two constants, e to the power beta x. Don't forget, beta is not allowed to be equal to 2. Now I want you to please differentiate this. So y dash x is equal to lambda times e to the power 2x into 2 plus e to the power beta x into beta. This is y dash. Write it properly. 2 lambda e to the power 2x plus beta e to the power beta x. What is y double dash x? 2 lambda as it is, again 2 e to the power 2x plus beta into e to the power beta x into beta. Perfect. This will give you 4 lambda e to the power 2x plus beta square e to the power beta x. Why have I computed y double dash? Yes? Why have I computed y double dash? Tell me quickly. Quickly tell me why. Because my solution had 2 arbitrary constants and my differential equation is of order 2. That is why I need to compute it twice to get the actual differential equation whose solution is this curve y of x. Okay, now that I have, this is y double dash, which is d square y by dx square. This is matching this. It's the same. Or in other words, I can say this d square y by dx square, please plug in place of this d square y by dx square. It's the same. It's the same. This d square y by dx square and this d square y by dx square is the same, right? So let's substitute this expanded version. 4 lambda e to the power 2x plus beta square e to the power beta x. This is in place of d square y by dx square plus dy by dx minus 6y is 0. Tell me if there is any confusion till here. Please tell me if there is any confusion till here. Now, in place of dy by dx, again, what will I plug in? I will plug in this. 2 lambda in place of dy by dx, okay? 2 lambda, this is e to the power 2x, okay, plus beta e to the power beta x. And minus 6y as it is, equal to 0. I have completely transformed my differential equation in terms of just x and y. There is no differential coefficient present in this current equation. Can you see that? Such a smart response. Such a smart response. Yes or no? Yes or no? So you are getting what? 4 lambda e to the power 2x plus 2 lambda e to the power 2x, which gives you 6 lambda e to the power 2x plus e to the power beta x common, b square plus beta minus 6y. What is y? Y is lambda. Again, substitute y also, na? Lambda e to the power 2x, okay, plus e to the power beta x. This is 0. Perfect. So you have 6 lambda e to the power 2x minus 6 lambda e to the power 2x plus e to the power beta x common. Beta square plus beta minus 1 is 0. This gets cancelled out. Now in this equation, guys, see this carefully. In this equation, obviously, this can never be 0. So only this part can be 0. So beta square plus beta minus 1 is 0. You will get two solutions from this equation. One is minus 3, one is 2. Tell me, are you getting or not getting? Plus 6 minus 6 will get cancelled out, no? My entire, this differential equation, entirely I have converted to an equation in terms of x and y. That's it. That's the beauty of this question. Yes or no? Quickly tell me. But beta is not allowed to be equal to 2. So I can't accept 2. Beta is minus 3. Now it's given. What do I need? I need y of 0. What is y of 0? Plug it here. Y of 0. This is lambda plus 1. I need lambda plus 1. But to get lambda plus 1, I need lambda. How will I get lambda? I am given y dash of 0 is equal to 5. This is what I am given. What is y dash? 2 lambda e to the power 2x. 2 lambda e to the power 2x plus beta e to the power beta x. This at x equals 0 is 5. This is what is given to me. I need lambda plus 1. Okay, I am using this piece of information given to me. Y dash of 0 is 5. So at x equals 0, this will give me 2 lambda plus beta equal to 5. But beta is minus 3. So 2 lambda is 5 plus 3, 8, which means lambda is 4. Plug the value here. Your answer is nothing but 5. 5 or not? Lambda is 4, yes. Your beta is minus 3. Plug the value of beta in this equation. Get lambda as 4. Plug the value of lambda back at y of 0 and your answer is 5. Hashtag HDCC. Is this clear? Is this clear? Absolutely clear. Yes or no? Crystal clear, ma'am. This is absolutely clear in my head. Yes, ma'am. No, ma'am. I want response. Come on. Keep the session interactive. Yup. Y of 0 is 5. Alrighty. Can I go to the next question? Very important. This type of question has been asked in JEE Advanced multiple times and it has started appearing in mains as well. Its variation, slight variation tweaked version or same version has appeared plethora of times in your advanced and mains exams. This is a very beautiful question which looks like an integral question, but actually it is a differential equation question. How? Understand. F is given from 0, infinity to 0, infinity. That means inputs are non-negative, outputs are non-negative. So the entire graph of F is drawn in the first quadrant. Always remember this. Whenever your inputs are non-negative, inputs are being picked up from non-negative x-axis, output is being produced on the non-negative y-axis. So the entire graph lies in the first quadrant. Non-negative x-axis, non-negative y-axis, everything on the first quadrant. That is where the graph lies. Correct? Okay. Continues on the entire domain of this function, which is closed 0, open infinity, differentiable on open infinity. If f of x is this, what is f of 6? Any idea? Any idea? How will you solve this question? Any idea? I want f of 6. I don't have f of x with me as yet. I don't have f of x with me. What will I do? How will I compute f of x? Until and unless I have my f of x, I can't compute f of 6. How to get f of x? Obvious answer. Differentiate both sides. Come on, f is a differentiable function. If your f of x is integral 0 to x under root f of t dt, release f from inside the integral. No. When you wish to release your x, free your x from inside the integral, obviously you will use something that will cancel the integral. What will cancel the integral? Derivative. They are inverses of each other. So differentiate both sides. You will get f dash x equals to under root f of x, that's it, plus c. Tell me, not plus c because I have used Leibniz rule. Actually, I have used Leibniz rule. We are through with different definite integrations one shot. If you have not watched it, please watch it. I have discussed Leibniz rule with fantastic quality questions. So I am differentiating both sides. When I wish to differentiate an integral which has at least one limit as variable, I use Leibniz rule to differentiate. Integrand of upper limit into dash of upper limit minus integrand of lower limit into dash of lower limit. Right? This is what I've got. This is what I've got. That means I've got dy by dx equal to root y. This is my differential equation. Dy by dx equals y to the power 1 by 2. So dy upon root y equal to dx. Variable separable, everybody. Variable separable. What is this? Integrate, come on. 2 root y equals x plus c. Now, in order to get my actual curve, I would need some initial value condition for sure. But I am not given any initial value condition directly. That f of this is this or the curve passes through this point. I am not given. But whenever we have questions like these, even while teaching you Leibniz theorem I had taught you, whenever we have questions like these, what do we do? What do we do? What do we do? We have a hidden initial value condition. You take the value of x to be the lower limit. Whatever is the lower limit, you take the value of x to be that lower limit so that upper and lower limit match and my entire integral vanishes, giving me a final value, which in turn is my initial value condition. The moment you take x as 0, you will get f of 0 equal to integral from 0 to 0, which is obviously 0. This is my initial value condition, which was hidden, not seen very clearly, but it was there. But it was there, right? So 0, 0, the curve passes through 0, 0, which means c is equal to 0. So you are getting 2 root y equal to x, or root y equals x by 2, or y equals x square by 4. So y of 6 will be 36 by 4, 18 by 2, which is 9. Hello, hello, hello. 9 is your answer, everybody. Please check. Root y is x by 2, y is x square by 4. So y of x is x square by 4. So y of 6 will be 6 square by 4. Hashtag HDCC, yes or no, everybody. I want a very quick, very loud response in the chat. Of course, you're not sitting in front of me, but I want all of you all to please tell me, have you understood? Have you understood this question, yes or no? Have you understood this question, yes or no? Tell me quickly. Yes, ma'am? No, ma'am? Yes? F of 6, the value is 9. The value is 9. 9 is your final answer. Okay? Okay? Now comes a different category of question again. What do you think is the answer of this question, and how do you think you can crack this question? Read the language. The language is little different from the ones that we've dealt before, seen before. Let a smooth curve. Smooth means differentiable, continuous differentiable. Smooth is a very beautiful curve. Let y equal to f of x be a smooth curve such that the slope of the tangent at any point on this curve is directly proportional to minus y by x. If the curve passes through 1, 2 and 8, 1, what is y of 1 by 8's mod? Very nice. Y, you know as a matter of fact that if the curve is y equal to f of x, I know dy by dx at any point P on the curve represents slope of tangent to the curve at the point P. So when it's written slope of the tangent at any point x comma y, dy by dx at any point x comma y will be dy by dx. This is directly proportional to minus y by x. Minus y by x. That means dy by dx is equal to minus ky by x. K is the constant of proportionality. This is my differential equation that I have to deal with, bachche. That's it. This was the only difficult part of the question. Otherwise, it's a cakewalk, supremely simple. Look at this. It's very direct variable separable. Very, very direct variable separable. Dy upon y is equal to dx upon x. And minus k is sitting outside. So log y equal to minus k log x plus c. Yes or no? Yes or no? Now this is my curve. My curve is passing through 1, 2. So 1, 2 will satisfy the equation. 1, 2. So log 2 equal to minus k log 1 is 0 plus c. So c is nothing but log 2. Plug it back. You are getting log y equal to minus k log x plus log 2. Solve, solve, solve. Yes, you are correct. So this will be log y equal to log of x to the power minus k plus log 2, which gives you 2 times x to the power minus k, and this is y. So this is your curve. You are getting the curve. You've got the curve, bachche. You've got the curve. But k is still unknown. K is still unknown. Now the question says the curve passes through 1, 2 and 8, 1. Very good. The curve passes through 1, 2. Let's say the curve passes through 1, 2. 2 is equal to 2. This is so cool. 2 is equal to 2. This is so cool. What will I do of this information? This information is of no use to me. This is just given to confuse me. Because 1, 2 point when I plug in here, I get 2 equal to 2, which is fine. Okay, fine. It's just a verification step that I have reached to the right curve. But 8, 1, let's plug in. 8, 1 equals to 2 into 8 to the power minus k. Yes or no? Which is 1 upon 8 to the power k. So you are getting 1 upon 2 equal to 1 upon 2 to the power 3k. Tell me what is k when you compare both these quantities. Can you see this? Okay, I'll come here. Otherwise, this will be hidden. 8, 1 I satisfied. I got 1 is equal to 2 into 1 upon 8 to the power k. That means 1 upon 8 to the power k is equal to 1 upon 2. 1 upon 8 is what? 1 upon 2 whole cube only, no? So, what are you getting? When the bases are same, we equate the powers. Remember? 1 is equal to 3k or k is equal to 1 by 3. Okay, if k is 1 by 3, my final curve comes out to be 2x to the power minus k minus 1 by 3. Yes or no? Which is nothing but 2 upon cube root of x. You want y of 1 by 8. So 2 upon cube root of 1 by 8. Which means 2 upon 1 by 2, your answer is 4. It's already positive. Mod of 4 will again come out to be 4. Mod of 4 will again come out to be 4. Hashtag HDCC everybody. Hi Priyanshu, so good to see you. 4 is the right answer. 4 is the right answer. Is this question clear, bache? Slope of tangent is dy by dx. Slope of normal, if the language said slope of normal, it would have been minus dx by dy. So if dy by dx at a point P represents slope of tangent to the curve at point P, then slope of normal to the curve at the same point P will be its negative reciprocal. That means minus dx by dy. Always remember that. Okay? Okie dokie. Let me jump on to the next question, which is supremely nice, and I want your attention on this question here. The answer is 4. Moving on to this question. This is very, very nice. It's a very nice question. Very nice question. Tell me, how will you crack this? Okay, Priyanshu, PNC. The video on PNC will very soon come on the channel. It is a recorded video. But what I've done in that video is, listen to me carefully, I have shared with you 6 questions. Through those 6 questions, I'm explaining you 10-15 concepts and 5 major tricks or ideas involved. These will complete the highest weightage portions from PNC, from where you can get questions in the paper. Right now, because we are so close to the exam, the very, very high weightage, part of PNC has been captured and covered in those 5 to 6 questions. Just watch that video. It's a short video and it will clear all your doubts about PNC. On Prob, I will come with a similar session very soon, bache. I am planning on keeping the sessions short but very impactful, very much useful, so that you can sit, watch it in just half an hour, 1 hour, the portion of PNC which is exam relevant, which can reap you marks 100% and which helps you revise those concepts which will make you feel confident about PNC as well. That part is covered for sure. Okay, just wait for, I guess, tomorrow it will be uploaded, at max tomorrow. Pakka. Okay. On probability, same thing I'm going to do very soon. Chalo, I said this is a very nice question. Why? dy by dx is x plus y minus 2 upon x minus y. Alrighty, it's a homogeneous differential equation for sure. Passes through the point 2, 1 and k plus 1, 2. K is positive, then. Is there something you can observe about this differential equation? The equation says dy by dx is equal to x plus y minus 2 upon x minus y. Yes, it's homogeneous, but it is of a certain category, of a certain type. The type which I shared with you. No, Priyanshu. The type which I shared with you just a short while ago. What is that type? The type is dy by dx equal to linear upon linear. That means line 1 upon line 2, where line 1 is not parallel to line 2. Where line 1 is not parallel to line 2. Isn't it? X plus y minus 2 is representing a line. X minus y is representing another line. But they both have different slopes. They are not parallel to each other. They both have different slopes. They are not parallel to each other. In such a situation, what do you do? Remember the algorithm? Do you remember the steps? Do you remember the steps? Quick. When you dy by dx is a very familiar category of differential equation. Yes, it's homogeneous. I'm not denying that it's not homogeneous. But you solve it using a certain algorithm which helps you very efficiently reach to your answer. What is that methodology? What is that algorithm? Or what is instead the first step? Just tell me the first step. No. Rest, everything is going to follow. What is the first step? Yes, Harry Potter is absolutely correct. Little bit gadbad in your answer. Small x bache, the variable which is already present in the equation, that we have to substitute. Small x is present in the equation, so this we will substitute with x plus h, and small y we will substitute with capital Y plus k. You have written ulta, you have written opposite, Harry Potter. Very good, very, very good. You people are able to recall. This substitution first of all ensures that dx is same as d capital X and dy is same as d capital Y. This much is pakka ensured. Now see the magic. Very nice question. dy is nothing but d capital Y, dx is nothing but d capital X. I am transforming the original equation. Okay, small x is capital X plus h, small y is capital Y plus k minus 2 upon small x is capital X plus h minus capital Y minus k. Now, capital X plus capital Y plus h plus k minus 2, this is separate. Capital X minus capital Y plus h minus k, this is separate. Okay? Yes. I have segregated the capital X, capital Y part, and whatever is left, I am putting it inside the bracket in the numerator also and the denominator also. Now, you remember the drill. I have a big smile on my face because I want you to recollect the drill. What was the drill? The drill said for a certain value of h and k, for a certain value of h and k, this becomes 0 and this becomes 0. And then my equation reduces to homogeneous. Now for what value of h, for what value of k will this become 0? See, h plus k minus 2 is 0, h minus k is 0. Solve both of them. Solve them simultaneously. If h is equal to k, you will get 2h is equal to 2 or h is equal to 1. H and k are equal, k is also 1. So when h is 1 and k is 1, when h is 1 and k is 1, then this substitution capital X plus 1 and capital Y plus 1 will land you with a homogeneous equation. What will you get? dy by dx is equal to capital X plus Y upon capital X minus Y. That's it. Rest everything is 0 for h equals 1 and k equals 1. That means for small x equals capital X plus 1 and small y equals capital Y plus 1. And in the end, how will I substitute? This when I will solve, I will get my answer in terms of capital X and capital Y. I want my answer in terms of the original variable small x and small y. So capital X I will substitute with x minus 1, capital Y I will substitute with y minus 1. In the end, this is for end. This is for end. Yup, absolutely correct, Priyanshu. Point of intersection of the two lines. This HK, both these equations in H and K are representing two lines. So when I am solving them simultaneously, it means I am finding out the point of intersection of these two lines. When the coordinates are that of the point of intersection, my equation transforms to homogeneous differential equation. Beautiful, isn't it? Now can you solve? It's very simple. Come on. You can write this as dy by dx is equal to 1 plus y by x, 1 minus y by x. Taking out x common from numerator and denominator and cancelling out. Perfect. Now y by x equal to v or y equal to vx. So dy by dx is equal to v plus x into dv by dx. Right? dy by dx is v plus x into dv by dx. Remember, we are talking about capitals. 1 plus v upon 1 minus v. Okay, so minus v here. You will be left with 1 plus v minus v plus v squared. This cancels out upon 1 minus v. So v square plus 1 upon 1 minus v is dv by dx with x here. So you will get 1 minus v upon v square plus 1. dv is equal to dx upon x. Variable separable. Variable separable. Yes ma'am, no ma'am, is this clear? Now of course I will separate integral 1 upon 1 plus v square or v square plus 1, this is more familiar, minus v upon v square plus 1 dv equal to integral dx upon x. Now this is very simple. 1 upon v square plus 1 upon x square plus a square is tan inverse x. Okay, minus, I will multiply by 2 and divide by 2. What will happen? V square plus 1 if I take as t, then 2v dv is equal to dt. So 2v dv is dt, so dt upon t, half integral dt upon t, which is log t, right? This is log t. What was t? What was t? T was 1 plus v square. I hope this is clear. Is equal to log x. Everything is capital. Everything is capital. Log x plus c. What is v, bachche? V is y by x. So tan inverse y by x minus 1 by 2 log of 1 plus y square by x square, which means x square plus y square upon x square. X square plus y square upon x square equal to log x plus c. Yes, Shreya, is this clear? Every step is absolutely clear. Please tell me. I'm reading the chat. Yes or no? Yes, ma'am. No, ma'am. Now, capital Y was small y minus 1. Remember? Capital Y was small y minus 1. Capital X was small x minus 1. Let's bring everything down to our original variables. So, tan inverse of y minus 1 upon x minus 1 minus half times log of, let me write this as 1 plus y square by x square only. Chalo, 1 plus y square by x square only. So 1 plus y minus 1 upon x minus 1 whole square equal to log of x minus 1 plus c. This is my actual curve which we are given is passing through 2, 1. Yes, we are given this is passing through 2, 1. This is passing through 2, 1. When you plug the value of x as 2 and y as 1, this becomes 0, y is 1, so this is also 0, log 1 is again 0, this is 0. This implies c is 0. Yes or no? C is pakka 0. So the remaining is my curve. Now it passes also through k plus 1, 2. If it passes through k plus 1, 2, plug in x as k plus 1 and y as 2, you will get tan inverse k plus 1, 2. 2 minus 1 is 1 upon k plus 1 minus 1 is k. Okay, alright. Minus 1 by 2 log of, what do you think will come next? This is y minus 1 is 2 minus 1, 1 upon k whole square. 1 plus 1 upon k square equal to log of k, c is already 0. Yes? Please tell me if this is clear. That means tan inverse, I'm just solving it further, 1 by 2 log of 1 plus 1 by k square plus log k. So this 2, I'll take out 2 as the LCM, 2 will come here, 2 will come here. 2 log k means log k square. So 2 tan inverse 1 by k, this is equal to log m plus log n. Yes or no? Log m plus log n is log of m into n. This is k square plus 1 upon k square into k square. Cancels out. So you're left with just this. Just this. So you are getting 2 tan inverse 1 by k is equal to log of 1 plus k square. Yes, log a plus log b is log of ab. Tell me if this is clear. 2 tan inverse 1 by k. 2 tan inverse 1 by k is log of 1 plus k square. This is absolutely correct. Okay, is that clear? This is a very nice category of question, bache. I have explained the theory of cracking this question, such a question, where you have dy by dx equal to ratio of two lines where the two lines are not parallel. But I had already told you, if you're finding it difficult to understand the theory of it, then Please wait for the question. This is how you attempt a question of that category. This is how you perform the substitutions, and this is how you convert such an equation to a beautiful, easy peasy homogeneous differential equations, which you know how to solve. Just in the end, remember, capital X substitute back in terms of small x, capital Y substitute back in terms of small y, then use the fact that the curve passes through this point, whatever point. Because these are bache values of small x and small y. These are not values of capital X and capital Y. So your curve will come in terms of capital X and capital Y. Again, plug back the values of capital X and capital Y in terms of small x and small y. Then you use these coordinates and make them satisfy the equation. From there you get the value of unknowns and the answer. Okay, done and dusted. Remember, done and dusted? Done and dusted. Perfecto. Can I move ahead? Everybody give me a quick good to go. Is homogeneous sinking inside you? Are you able to now understand that how easy homogeneous is? Yes or no? Homogeneous is supremely easy. Variable separable is supremely easy. Now, let's attack this question. Advanced level, but very simple. Again, based upon the same logic that I had explained you in the previous question. Shifted. Remember, when you replace small x with capital X plus h, replace small y with capital Y plus k, you are actually shifting. Translation. Based upon the same thing, here is a question. Look, what is written? See what's written. If you understand the language, this question will be very easy for you. Let f of x comma y equal to 0 be the solution of this homogeneous differential equation. Alright. If f of x plus alpha comma y minus 3 equals 0 is the solution of this differential equation, then what is alpha? People are playing very smart with us, na? Very smart, they are playing with us. What is the meaning now? See, the differential equation given. What is it? 2x plus 5y dx minus x plus 3y dy equal to 0. This is the original given differential equation whose solution is f of x comma y equal to 0. Okay. Okay. And there is a new differential equation. What is it? 2x plus 5y minus 1 dx plus 2 minus x minus 3y dy equal to 0. Its solution is f of x plus alpha comma y minus 3 equal to 0. What do you understand? Yes, second part is just labor. Very, very correct. Why? Because try to solve this new differential equation. Please try to solve this new differential equation. What will you get? You will get dy by dx. Take this to that side. Dy by dx will come out to be 2x plus 5y minus 1 upon x plus 3y minus 2. Please check. Okay. Now, again the same concept. This is line 1 upon line 2, where line 1 is not parallel to line 2. So, what will you ideally do? You will replace small x with capital X plus h and small y with capital Y plus k, and in that, after that substitution, when you will substitute back, you will get your homogeneous equation in terms of capital X and capital Y, and its solution will come out in terms of capital X and capital Y. So I can say the solution then will look like f of capital X and capital Y, which is same as f of what is capital X? Small x minus h and small y minus k. This is how the solution will look like. This is how the solution will look like. No. And the question says the solution actually looks like f of x plus alpha and comma y minus 3. The solution actually looks like f of x plus alpha comma y minus 3. That means the value of alpha is minus h and the value of k is bache 3. The value of alpha is minus h and the value of k is 3. Are you getting my point? So H is nothing but minus alpha, I can say. H is nothing but minus alpha, K is 3. Is this part clear? Is this part clear? See, please understand the flow. The flow is the same as that of the previous question. This differential equation, the new differential equation, the shifted differential equation looks like L1 upon L2 where L1 is not parallel to L2. In such a question, to crack such a differential equation, we substitute small x with capital X plus H and small y with capital Y plus K. When I use this substitution in my original equation, it transforms it to what? A homogeneous differential equation in terms of capital X and capital Y. When you solve that, your answer, your solution curve comes out to be in terms of capital X and capital Y. It looks like this. Then we always substitute back. Capital X we plug in as small x minus h. Capital Y we plug in as small y minus k. So my solution looks like this eventually in terms of small x and small y. But question says this solution looks like f of x plus alpha comma y minus 3. So these both are same only, na? These both are same only. Yes or no? From there, when you compare, you get h is nothing but minus alpha, k is nothing but 3. So now when you continue solving, this will give you dx equal to dx and dy equal to dy. Perform now. Perform the calculation. This is 2 times small x is capital X plus h. 5 times small y is capital Y plus k minus 1. This is upon x, which is capital X plus h, plus 3 times capital Y plus k minus 2. So you are getting 2 capital X plus 5 capital Y plus 2h plus 5k minus 1 whole upon capital X plus 3 capital Y plus h plus 3k minus 2. What is the drill after this? What does the algorithm say? Everybody, do you remember? Algorithm they says for some value of h and k, both of them will be 0. For some value of h and k, both of them will be 0. That means 2h plus 5k minus 1 will be 0 and h plus 3k minus 2 will be 0. I have to solve both these equations simultaneously to get the value of h and k. But the value of k I already know, na? The value of k, bachche, I already know. So plug that value of k in any one equation. Plug the value of k equal to 3 in any one equation. What will you get? H. Yes. What is h? This implies h is minus 7. So corresponding to h minus 7 and k3, my linear part is going to vanish and what I will be left with is just 2x plus 5y upon x plus 3y differential equation. Okay, so if h is minus 7, I know h is minus alpha. If h is minus 7, alpha is nothing but 7. Bingo, my question is done. I was not supposed to solve this differential equation dy by dx equal to, this is capital Y. This is d capital Y, d capital X. This is also d capital Y, d capital X. I was not supposed to solve this homogeneous differential equation. My hk part has vanished for what values of h and k? H minus 7, k3. Now, ideally, I should be solving this, but I am not being asked to solve this. I am not being asked to solve this differential equation which is homogeneous. No. I just need the value of alpha and it was my observation, my understanding of the concept that alpha is nothing but minus h. If you understood this concept, yes. Wow, thank you. Yes, it is an advanced concept, advanced PYQ. But before this PYQ, I had solved this question with you, no? So that you can understand the flow, you can understand the logic, the algorithm, why, what happens, how it happens. Because that understanding, I have just used it in this question. I have not actually solved a differential equation in this question. I have just used my understanding, my fundamental basic understanding about this type of differential equation I have used here. Which type? Which looks like dy by dx equals L1 upon L2 where L1 is not parallel to L2. Very, very, very important. Very important. All right. So we are through with variable separable 100%. We're also through with homogeneous, reducible to homogeneous, reducible to variable separable. All these forms we've covered. Now it's time to attack What? Linear differential equation, which you all know is the favorite of NTA or favorite of JEE Main. This is actually favorite of NTA. I should write favorite of JEE Main. Okay, we're going to take a quick 10-minute, 15-minute break and we'll come back and start this fantastic topic of LDE, after which I'll take you through the topic of exact differential equation, which is a pain point for a lot of students, but I will help you make it easy, supremely easy. Okay, all right. I have part test on vectors in ITF. Well, please watch the session on vectors in ITF on YouTube. I have taught it when I have discussed high weightage, most important top questions on vectors and ITF. If you don't have time too much right now to study from the basics, I hope you have already prepared the chapter to some extent. Revise the formulas, revise the basics. Also, whatever questions you've solved, just skim through them so that wherever you've committed the mistake, that you can capture in your head. And before you sleep, definitely review your mistakes. Before you take a sleep, before you go to your sleep, you collapse in your slumber, you have to take a look at your mistakes and you have to take a look at the formulas. All these things while you're sleeping will get embedded in your system, and tomorrow during the paper you will not commit the same mistake. If there is anything peculiar about a question which you missed when you were solving, that part will also get registered in your memory, and the formulas, the tricks, the shortcuts which you have breezed right towards the end will also get digested in your memory, stuck in your memory. All right, use these tips and let me know how does your paper go tomorrow. All right, all the very best. I'm going to be back, people, at 9:45. All right. All right, we're left with LDE and exact. Let's meet very soon at 9:45. Okay? All right. Is it audible? Okay, is it audible now? Yes? Okay. So, okay. The topic that we are now about to attack, people, is the highest weightage, most important, most loved by NTA, which is linear differential equations. And here also, just like the previous two cases, we have linear and reducible to linear. When you say reducible to linear, another name for it is Bernoulli's equation. So we had variable separable, reducible to variable separable, homogeneous, reducible to homogeneous, linear, reducible to linear. Correct? Let's see how a linear differential equation looks like. A differential equation of first order, first degree. What is the look that we are chasing, which is supposed to be identified when you get a question? Look at this. A linear differential equation has dependent variable and its derivative in the first degree only. That's what is in our syllabus. Dependent variable and its derivative are not multiplied together. So y into dy by dx or sine y into dy by dx. No. All derivatives are in polynomial form. Okay? Got it? Order is 1, degree is 1. Perfect? Now, let's identify the look. The very first look of a linear differential equation is dy by dx plus py equal to q. Please remember this, people, dy by dx plus py equal to q, where p and q are functions of x or constant. So they can be some constant or they can be functions of x. Okay, what do you do? What do? You find the integrating factor of this differential equation, which is e to the power integration of p dx. Then you multiply this integrating factor to the left hand side and the right hand side of the given equation. When you do that, on simplifying, you end up getting the solution of this differential equation, which is something you can directly remember, that is y into integrating factor. Y into integrating factor is integration of q into integrating factor dx plus c. This is the solution. So please remember 3 steps. Your equation will look like dy by dx plus py equal to q, where p and q are functions of x or they can be constants also. What do? You number 1 compute the integrating factor, which is e to the power integration of p dx. Number 3, once you have the integrating factor, you write the solution directly. No need to perform this entire process. No. This is just to show you how do we reach the solution. It's a proof, a derivation. But next step is what? You write the solution directly, which is y into integrating factor is integration of q into integrating factor dx plus c. Now you can also get another variation of this linear differential equation, which is of the look, that is this. dx by dy plus px equal to q. dx by dy plus px equal to q, where p and q are, bachche, this time functions of y or constant. Getting my point? Integrating factor e to the power integration of p dy, and the same logic applies in the solution. X into integrating factor is integration of q into integrating factor dy plus c. So just interchange x and y and you will get the solution. Okay, these are your 2 very, very famous, very promising and very prominently occurring linear differential equations. dy by dx plus py equal to q, where p and q are functions of x or they can be constants, and dx by dy plus px equal to q, where p and q can be functions of y or constants. Alright, Bernoulli's equation is an equation which is that differential equation convertible to linear. So till now we did not have a specific name for equations convertible to variable separable, convertible to homogeneous, but this time equations convertible to linear differential equation is called Bernoulli's equation. So here is an example. Suppose you have dy by dx plus py equal to qy to the power n. It's very evident that when you look at this equation, what strikes the doors of your memory is it somehow is very, very close and similar to linear differential equation. But it's not exactly a linear differential equation because of this extra y to the power n kept here. So what will you do? You will divide the entire equation by y to the power n, right? When you do that, you will get this. Here, just substitute y to the power 1 minus n as, let's say, v. When you do this, what will you get? Look here. When you substitute y to the power 1 minus n as v, differentiate, what do you get? Just see, y to the power minus n dy by dx you can simply replace with this term. This term. On substituting, what you end up getting is a very beautiful linear differential equation. So this is one of the formats of an equation which is convertible to linear differential. For example, suppose I have such an equation. xy square dy by dx plus y cube cot x equal to x. Now this one is not a linear differential equation, but this one is a Bernoulli's equation. How will you solve this? I will say, suppose y cube is equal to t. Listen to me carefully. How is this Bernoulli? My claim is that this is Bernoulli's equation. Correct? 3y square dy by dx equals dt by dx. So y square dy by dx is equal to 1 by 3 dt by dx. Alright, plug it back. X as it is. Y square dy by dx is 1 by 3 dt by dx. Y cube already is t and this is cot x equal to x. Yes, Vishnu, is everybody understanding? Is everybody understanding? So dt by dx. Now what I have to do is, x by 3 I have as the coefficient of dt by dx. I want to make the coefficient 1. So divide by x, multiply by 3. So 3 by x. I'm going to multiply throughout by 3 by x. I will get what? T times 3 by x cot x equal to 3 by x into x will give me just 3. Now replace t with y, all dummy variables. You will get dy by dx plus 3 by x times y equal to 3. This is a perfect linear differential equation. Dy by dx plus py equal to q. This is p, which is a function of x, and this is q, which is a constant function. So q of x is actually equal to 3, which is a constant function. Is this cool? What will you do now? You will compute the integrating factor e की power integration of 3 by x dx, which is e to the power 3 times log x, which is x cube. So x cube is your integrating factor. Oh, I missed cot x. Oh, I missed cot x. You people are also not reminding me. I missed cot x. Okay, 3 by x into cot x, y equal to 3. This completely is my p of x and this obviously is my q of x. Now compute the integrating factor, which is e to the power integration of 3 times cot x by x dx. Tell me. Okay, you're multiplying by 3 by x. So this x will also get cancelled out, no? Yes. Is that clear or not? Please calculate the answer here. I have x by 3 dt by dx plus t times cot x equal to x. Okay. Acha, this x is not there, no? Okay. Wait a second. Please wait a second. This x is not there. I have by mistake written it. This x is not there. So this x is also not there. Okay. Now just multiply throughout by 3. So this x will not come. And here I will get 3x. Okay. Got it. This is 3 cos x, cot x. 3 cot x into t. Is this cool? So dy by dx plus 3 cot x times y equal to 3x. Is this cool, Pankaj, Vishnu? Okay. This is e to the power 3 times, what is integration of cot x? It is log sin x. So sin x whole cube. Is this what you are getting as the integrating factor? People quickly tell me. Sin x whole cube, is this what you are getting as the integrating factor? So y into integrating factor is equal to integration of q into integrating factor dx plus c. This is your solution. And of course, on the right hand side, you will apply your by parts and then calculate the answer. Yes? Is that cool? Is everything perfect? Did you understand how actually we deal with Bernoulli's equation? So the equation did not actually fit into the linear differential equation setup, its model, its standard look, but it was Bernoulli because after a beautiful, cute little substitution, we were able to convert it to a linear differential equation of first order. Alright, and then you know how to solve it. By parts. Yes, Pankaj, by parts then. How about this one? Sin y dy by dx minus cos y into x equal to x square. Please tell me. Now you just saw that dependent variable can't come with differential coefficient. So sin y into dy by dx, that's not allowed in a linear differential equation. But this is convertible to linear differential equation. How? Can you tell me? This can very easily be converted to linear differential because minus cos y, if you take as t, what are you getting? Sin y dy by dx is equal to dt by dx. So sin y dy by dx is dt by dx. Minus cos y is t into x equal to x square. You can replace t with y, you will get dy by dx plus py equal to q. So x is your p and x square is your q. That's it. Now it's linear. Very good, Pankaj. Yeah, plus cos t or minus cos t doesn't make a difference. Just a minus sign difference. Your answer will come out to be the same. This is your linear differential equation. Now I guess you'll be able to solve it very, very easily. Yes, ma'am. No, ma'am. You'll be able to solve it easily. Understood? So linear and Bernoulli, these two we have to deal with very precisely because they are holding maximum weightage in the paper and they are repeated maximum number of times in the paper from differential equation. Many times it has happened that two questions have come from differential, both linear. Okay, so that is why this is very important. Come to this question. Awesome question, people. Let this be the solution of this differential equation. X of 1 is 0, x of e is equal to what? Who will tell me? Who will tell me? Tell me quickly. It's not that difficult. What is written? Y into dx by dy. So it's linear differential of another type. Equal to 2x plus y cube times y plus 1 e to the power y. Obviously, I can anticipate that it can look like dx by dy plus px equal to q. So I need to make dx by dy is coefficient 1. Very good, very good, Pankaj. Coefficient I want to be equal to 1. Divide by y, divide by y, divide by y. So you are getting dx by dy equal to px. So 2 by y times x plus another function of y, which is y square into y plus 1 e to the power. Bingo, people. This is your linear differential equation. Correct? This is your p and this is your q. Integrating factor, guys. Integrating factor is e to the power integration of 2 by y dy, which is e to the power 2 times log y. So y square is your integrating factor. Quickly tell me, is y square your integrating factor? 2 by y. Please tell me. 2x divided by y. Is this cool? Dx by dy plus px equal to q. I want plus px equal to q. Very good. Plus px equal to q. So bring it on the left hand side. This will be minus. That means plus here, minus here, equal to q. Now it's of standard type. Did you understand such a slight mistake I committed? Dx by dy plus px equal to q. I did not realize that my p was sitting on the right side of equality sign. It should actually sit on the left. Then whatever p is, that I have to use in my integrating factor. So this is minus 2 by y. So minus 2 log y to the power minus 2, which is 1 upon y square. Such a slight mistake, such a slight mistake. Now I am ready to write the solution. X into integrating factor is integration of q. What is q? Y square into 1 plus y e to the power y into integrating factor dy plus c. This and this gets cancelled out. So x upon y square is integration of 1 plus y e to the power y dy plus constant of integration. Tell me, Pankaj, Harry Potter people, are you solving? Are you solving? Because here again I'll be using bypaths only. Bypaths only, ILATE, this is first function, this is second function. First function integration of second minus integration of differentiation of first into integration of second dy plus c. This is 1 plus y e to the power y minus e to the power y plus c. This is x upon y square. So I have got my answer. This is my curve. My curve is passing through 1, 0, but remember, x of 1 is 0. When y is 1, x is 0. So 0, 1 is the point which is lying on the curve. 0, 1 is the point lying on the curve when x is 0, y is 1. When x is 0, y is 1, what is the value of c? When x is 0, y is 1. When x is 0, y is 1. So 2e minus e plus c. So c plus e is 0. C is equal to minus c. Are you getting this? C equal to minus c. Plug it back. Plug it back. You get x by y square is equal to 1 plus y e to the power y minus e to the power y minus e. I want x of e. When y is e, what is x? So this is e square. When y is e, 1 plus e to the power e minus e to the power e minus e. So you will get what? E to the power e plus e times e to the power e minus e to the power e minus e. This gets cancelled out. You're left with e to the power e plus 1 minus e. All of this into e square is x. Please check. Please check. You can take out one more e outside. So e to the power e minus 1 into e cube. Pankaj, what is your answer? Is this your answer? E cube into e to the power e minus 1. See, when the question says compute x of e, which means when y is equal to e, x is equal to what? So when you've got the actual curve, in there plug in y as e and correspondingly compute x. That is the demand. That is what is the question is demanding. Okay? Alrighty. Is this question understood, people? I want a hashtag HTCC in the chat. Is this clear? Absolutely clear? Yes or no? Is it absolutely clear? Yes? Perfect. Smoothly synced in. It has gone inside your head, gone inside your system. You understood it nicely. I am now going to move on to the next question, people. I want all of you all to quickly, okay, take a look at the next question. This one is sorted. E cube into e to the power e minus 1. Okay, come at this question. Beautiful mixture of calculus. Beautiful mixture of calculus. Let y be the solution of this differential equation with y of 0 equals 1 by 3. The point x equals minus 4 by 3 for this curve is what? Is it a critical point, not a critical point, point of local max, point of local min, point of inflection? What is it? Quick. Until and unless I know the curve, I cannot comment upon this point being what for this curve, right? I want the curve. Now my curve is a solution of this differential equation. So let's solve this differential equation. What are you getting? See, x plus 1 dy by dx minus y equal to e to the power 3x into x plus 1 whole square. Obviously, this looks like dy by dx plus py equal to q. For that, I want the coefficient of dy by dx to be 1. So I will divide by x plus 1. I will get dy by dx minus 1 upon x plus 1 into y, or rather plus here, minus here, equal to e to the power 3x, x plus 1 whole square upon x plus 1 will give you just x plus 1. Perfect. This is your linear differential equation, bache. Right? What is this? dy by dx plus py. This is your p equal to q. Perfecto. Integrating factor, people. E to the power integration of minus 1 upon x plus 1 dx, which is e to the power minus log of x plus 1. What is it? Yes, no? This is what? X plus 1 to the power minus 1, so 1 upon x plus 1. Generally, log of mod x plus 1 comes, but here we are not given any restriction upon x, so you can assume it to be positive. If there is some restriction given, accordingly we have to decide that from the mod which value will come out. Okay, if it was mod of x plus 1 and some restriction upon x was given, then we would have decided that x plus 1 will come out of mod or minus x minus 1 will come out of mod, depending upon x is greater than equal to 1 or less than equal to 1. Greater than equal to minus 1 or less than equal to minus 1. Alright? Cool. Solution. Y into integrating factor is integration of q. What is q? E to the power 3x into x plus 1 into integrating factor dx plus c. This gets cancelled out. So y upon x plus 1 is equal to e to the power 3x upon 3 plus c. Easy peasy lemon squeezy. Y of 0 is 1 by 3. So 0 comma 1 by 3 is a point lying on this curve. Okay, so 1 by 3 upon 1. Okay, e to the power 0 is 1. This is 1 by 3 plus c. That means the value of c is 0. So what are you getting? Y upon x plus 1 is e to the power 3x upon 3. This is my curve. Now I want y. What is y? Y is 1 by 3x plus 1 into e to the power 3x. This is y. I have to do a post-mortem of y. What is y? 1 by 3 times x plus 1 e to the power 3x. मैम सारे आ गए, ऑप्शन नहीं समझ आ रहे हैं. अच्छा, ऑप्शन क्या है? अच्छा, सारे ही आ गए क्या? सारे ही आ गए क्या? चलो, cool. Let's see. Y, this is your f of x. Obviously, to find out point of max or point of min or critical point, point of inflection, whatever, I have to compute the derivative. Please understand one thing. What is a critical point? Where your derivative is undefined or doesn't exist, as well as where your derivative is 0. Now, this is everywhere differentiable function. So, there is no x at which f dash is not defined, right? That means all my critical points will be those points only where f dash is 0. Okay? So, just compute f dash 1 by 3 as it is. First function, differentiation of second plus second differentiation of first. So, what are you getting? 1 by 3 e to the power 3x, 3 times x plus 1 plus 1. So, this is e to the power 3x upon 3, 3x plus 4 equal to 0. Now, this part is always positive. This is always positive. So, only this can be 0. To make my f dash 0. So, when you say 3x plus 4 is 0, x comes out to be minus 4 by 3. Bachche, this is the only critical point. This is the only critical point. And minus 4 by 3, obviously plus here, minus here. That means this is a point of minima. Minus 4 by 3 is a point of minima. Inflection point, well, because here your function, this curve, is continuous and differentiable throughout the real line, if there would have been some critical point about which the sign is not changing, if there would have been some critical point about which the sign of f dash is not changing, that point we would have declared as critical point. Okay, sign of f dash doesn't change, but when you compute f double dash, the sign of f double dash changes. That becomes your inflection point. But here there is no such point about which the sign of f dash is not changing. There is only one critical point, minus 4 by 3, about which the sign is changing from negative to positive of f dash. That means the graph is decreasing before minus 4 by 3, increasing after minus 4 by 3. This is definitely point of minima. Is that cool? Is that cool? Yes, so I hope there is no confusion now related to the options. Very nice question based upon a mixture of AOD and differential equations. JEE Main is now becoming super famous super popular for mixing concepts of different chapters. And that is why it is non-negotiable for you to leave any chapter before you go for the exam. Leaving any chapter completely, like from start to finish, that you have no idea whatsoever, is a flop decision. Trust me, it's a flop decision. At least skim through the basics, at least get clear with the fundamentals, at least take a look at the standard questions, easy questions which have been asked from that chapter. What are the must-do concepts or subtopics from that chapter? At least do this much. Solve 2020, 2021 PYQs. Those were easy PYQs, easy papers basically related to 2022, 2024, right? 2020 and 2021 were relatively easier papers. So if you're shit scared of any chapter, just do its basics, understand the fundamentals and solve PYQs of those 2 years. Okay, at least till a basic level you will be prepared. If an easy question comes in your paper from there, you will be able to smash it. If some supremely difficult question comes, as it is, many people more will not be able to do. Okay? Alrighty, come to this question now. Very nice. Very, very, very nice question, people. I want you all to please crack this question with full sincerity, understand it very nicely. This was, or this is a 2014 JEE Advanced PYQ. This was asked way before in 2014 in the advanced papers, and after that its tweaked versions have been asked in JEE Main many times, and still it happens to be one of the favorites of NTA to land in the JEE Main exam. So you have to understand how to think in this question, how to crack this question, what is the approach, what is the pedagogy, what is the flow, how are we unlayering, how are we reaching the solution. Because if this question comes in any tweaked version, any modified version, you should be able to understand and crack it. Okay, Pankaj, I have done a beautiful one shot on binomial. Please go watch it. Please go watch it. Everything which you are bound to not understand also, I can guarantee you will understand in a very easy way, because that's my forte. I make difficult things super easy for you to understand. Tell me now, dy by dx plus xy upon x square minus 1 equal to whatever, when x comes from minus 1 to 1, passes through origin. What is this integral equal to? Now this is given to us in a linear differential equation format. See, dy by dx plus x upon x square minus 1 times y equal to x to the power 4 plus 2x upon root over 1 minus x square. So this is like function of x, function of x. This is proper linear differential equation. Yes or no? Correct? I will just directly compute the integrating factor e to the power integration of x upon x square minus 1 dx. Obviously, multiply by 2, divide by 2. So that when I take x square minus 1 equal to t, I get 2x dx equal to dt. What will this make my integral into? E to the power 1 by 2. 2x dx is yes dt upon t, right? So 1 by t is log t. Yes or no? Yes or no? This is t to the power half, root t. Root t means root over x square minus 1. But there is a catch. Yes, there is a catch. This is not log t, this is log mod t. Log mod t, right? Which means mod t to the power half. Which means mod of x square minus 1 to the power half. What is mod of x square minus 1, Baba? If you talk about x square minus 1's mod, this is x square minus 1 when x square is greater than or equal to 1. And it is 1 minus x square when x square is less than 1. Over here, x is coming from minus 1 to 1, so x square is strictly less than 1. No, that means I will use this definition. Mod of x square minus 1 is actually 1 minus x square. This will be 1 minus x square to the power half, which is root over 1 minus x square. Yes, minus is going to do its magic. Very beautiful, tricky step, where you were not supposed to take log t, you were supposed to take log mod t, because a very strong restriction upon x was given, which ensured that x square is strictly less than 1, and that is why mod opened out with a minus sign. Yes? This is cool, root over 1 minus x square. Now y into integrating factor is integration of q into integrating factor upon is the same integrating factor, so cancels out dx plus c. So y into root over 1 minus x square, this is what? X to the power 5 by 5 plus x square by 2, okay, plus c. Is this what you are getting? Integration. हाँ, 0 होगा कि नहीं होगा बताओ? क्योंकि this curve is passing through 0, 0. So plug in x as 0, y is 0, you are getting c is 0. So you are getting y into root over 1 minus x square is x to the power 5 by 5 plus x square. This is your final curve. Yes ma'am, no ma'am? This is your final curve. So what is f of x equal to? Can you tell me? You want f of x, right? Because otherwise you will not be able to integrate, no? So what is f of x? What is y? This is x to the power 5 upon root over 1 minus x square, all of this into 1 by 5, that's the constant part, plus x square upon root over 1 minus x square. Yup, this is your f of x. This is what you need to integrate. So let's start with the major portion. Till now we were solving the differential equation, plugging in the initial value condition to get the value of c. Now that we have the final curve with us, f of x with us, what are we doing? We are doing the integration. So integration minus root 3 by 2 plus root 3 by 2 f of x dx is what? Break it. Minus root 3 by 2 plus root 3 by 2 1 by 5 times x to the power 5 upon root over 1 minus x square dx, and next will be minus root 3 by 2 plus root 3 by 2 x square upon root over 1 minus x square dx. Now it's very simple. You must remember definite integration. Integral minus a to a. Remember even odd property? If the integrand is odd, integral straight away is 0. If the integrand is even, integral is 2 times integral 0 to a. Remember, if it is neither even nor odd, we applied the King's property. Here, x to the power 5 is an odd function and this is an even function. Odd upon even completely is an odd function. So minus a to a, the value of this integral will be completely 0. Big fat 0. Bye-bye integral. Bye-bye. What about the next one? This even. So the ratio also even. So in the next step, I will write it as 2 times integral 0 to root 3 by 2 x square upon root over 1 minus x square dx. This is the only part left for us to solve. What is it? 2 times integral 0 to root 3 by 2. This is x square upon root over 1 minus x square. Can anybody tell me, if you have studied indefinite integration, definite integration, can you tell me how to solve this integral? There are 2 ways, very famous ways, very nice ways, but one is an easier way, one is a more difficult way. Anybody, any clue? Anybody, any clue? Tell me. Anybody? One way is you can add a 1, subtract a 1. So x square or 1 minus x square, 1 plus x square is what I mean. Then under root will get cancelled out. Your integral will get simplified and broken into 2 integrals. Another method is what? Yes, Vijay, that is correct. You can do that. Another method is plus 1 minus 1. You can do that. But that will compel you to use your formulas for under root a square minus x square and all. Those formulas you should know to use this method of plus 1 minus 1. Another method is substitution. Substitute x as sine theta. Remember? Remember or not? Dx equal to cos theta d theta. So what will this become equal to? 2 times integral. When x is 0, that means theta is 0. When x is root 3 by 2, that means theta is what? 60 degrees or pi by 3. X square means sine square. And root over 1 minus sine square is cos square, which gives you cos theta. Because in 0 to pi by 3, cos is positive. Tell me, and what is dx? This is cos theta d theta. Cos cancels out. We're left with 2 times integral sine square 1 minus cos 2 theta upon 2. Is sine square 0 to pi by 3 d theta. Can you solve this now? Can you solve this? Huh? This will give you what? Theta minus sine 2 theta upon 2, and this is from 0 to pi by 3. So this will give you pi by 3 minus, this is 1 by 2. Okay, correct. 2 pi by 3. Tell me. Quickly, quickly, quickly. There are, jaldi bolo, jaldi bolo. Did you understand or not? Did you understand or not? Sine pi by 3 is what? Sine 60, root 3 by 2. Minus 0 and then 0, 0 only. Tell me, are you getting this? Clear? Pi by 3 minus root 3 by 4 is the answer of this integral. Such a brilliant question, yaar. I mean, right from the moment when we wanted to compute this integral, one thing which should straight away strike your head automatically is minus a to a integral f. This is nothing but 0 if f is odd and 2 times integral 0 to a if f is even. Both the situations came here. One part was odd, one part was even. So nice. So nice. Yes? Is this clear? Is this question hashtag HDCC? I loved it. People have written hashtag HDCC. Great. Perfecto. And now it's time for the next question. Are you ready, people? Are you ready for the next question? Let's go to this one. This is fantastic, very nice, beautiful question. A 2022 JEE advanced question. Pretty good. Again, they have tried to mix differential equations with AOD. Tell me, for x belongs to R, let the function y be the solution of this differential equation. Which of the following statements is or are true? Y is increasing, decreasing. There exists a real number beta. I'll just move here. Oh, why is there? Okay. There exists a real number beta such that the line y equals beta intersects the curve at infinitely many points and y is a periodic function. Let's go. Let's go. Now you have to listen to me very carefully because in this question I will share with you a bomb shortcut, a nuclear bomb shortcut. See, the question says dy by dx plus py equal to q. Perfect. 12 is my p and this cos function is my q. Perfect. What is integrating factor? E to the power integration of 12 dx, which is e to the power 12x. E to the power 12x is my integrating factor. What is the solution? Y into integrating factor is equal to integration of q cos pi x by 12 into e to the power 12x dx plus c. Who will tell me what to do after this step? I want to reach to the answer. For that, I will have to perform this integration. For that, I will have to perform this integration. No. I had a differential equation. It is perfectly fitting the look of linear differential equation. So I computed the integrating factor. Now I wrote the solution. Y into integrating factor is integration of q into integrating factor dx plus c. But to further simplify it, I need to integrate this part. No. How do you think I should integrate? How do you think I should integrate? How do you think I should integrate? Tell me. If you think, ma'am, apply the Eilert rule, let me tell you, it's not a simple road. It's not a simple road. You will take this as the first function, take this as the second function, and right in the first round of Eilert, your integral will not be simplified. Again, you will have to apply Eilert, and that is why it's a very lengthy process. Rather, I want you to please write this shortcut which will help us remember this type of an integral and solve it, or rather simplify it in a fraction of a second. When this question came in advanced 2022, only those students who remembered the shortcut, which was a direct answer to such an integral, were able to crack this question in a very short span of time. Otherwise, people have spent so much time on this question, can't tell you. They even got demotivated in between and left it. That is not something that I want for my students. So please write. Can you write? You'll write. Yes, e to the power ax cos bx. How many of you all know? How many of you all know? What is this? E to the power ax upon a square plus b square. What inside? Anybody remembers? Partially I've written. Anybody remembers? Huh? Tell me. A cos bx plus b sine again bx. Will you remember? Will you remember? And similarly, if I had e to the power ax sine bx, let's say, dx. This is e to the power ax upon a square plus b square. A sine bx minus b cos bx. Very, very good. These two bache are must remember. I don't always ask you to cram, but these are very easy to first of all remember because they follow a very beautiful pattern. And moreover, please understand, to solve this integral, you would need a lot of time, and JEE Main is very much about speed and accuracy balance. So this integral is not worth spending time upon because it's easier to remember this result. If you ask me, ma'am, summation r NCR, summation r square NCR, those also we must remember. Yes, you should remember, but even if you don't, it takes a few seconds to actually in the rough work derive its result. So that I don't emphasize too much upon remembering. When it comes to students asking me, ma'am, should we remember that or not? Summation r square NCR, summation r NCR whole square, all these formulas. I don't emphasize too much upon remembering them, cramming them, learning them by heart because it just takes few seconds that you can derive them. So it's okay. But this one will take a lot of your time. This will cost you a lot of your energy, time. It's not worth it. Please remember the direct formulas. Okay, so I have y into e to the power 12x is integral of what? Cos pi x by 12 e to the power 12x dx plus c. So e to the power ax into cos bx. A is 12, b is pi by 12. What is the integral? Remember, e to the power ax upon a square plus pi square by 12 square, a square plus b square. A cos bx, 12 cos pi x by 12, a cos bx plus b sin bx. Is this clear? This is your answer. E to the power 12x and this is plus c. Tell me. Quickly tell me. Is this cool? Yes? Perfect. Just divide by e to the power 12x so that we just have y remaining. So y of x comes out to be e to the power 12x, e to the power 12x, and here I get e to the power minus 12x. Perfect. So I get 12 cos pi x by 12 plus pi by 12 sine pi x by 12, all right, upon 12 square plus pi by 12 square plus c e to the power minus 12x. This is my y. This is my y. Now what do I need? Y is the solution. Question says y of 0 is 0. So 0, 0. Tell me, if 0, 0 is lying on this curve, if 0, 0 is lying on this curve, what is the value of c? If 0, 0 is lying on this curve, what is the value of c? Guys, if you've not liked the session, you must like the session right now and also subscribe to the channel straight away. Very close to JEE Main exam, all this effort needs to be acknowledged by you and it should be reciprocated by you as well. Right? It's a two-way street, not a one-way street. All right. When x is 0, y is 0, left hand side is 0. Here you get cos 0 is 1, sin 0 0, and this is just c. So 12 upon 12 square plus pi by 12 whole square plus c. Yes or no? 0 is equals to, this is 12, right? 12 upon 12 square plus pi by 12 whole square plus c. Yes? So c comes out to be equal to minus 12 upon 12 square plus pi by 12 whole square. This is my c. Okay, fine. What next? Plug in the value of c back. Plug in the value of c back, you will get y of x is equal to 12 cos pi x by 12, perfect, plus pi by 12 times sine of pi x by 12, alright, plus c, which means minus 12 e to the power minus 12x upon whole upon 12 square plus pi by 12 whole square. Yes, beautiful, beautiful, beautiful expression for y. Now tell me one thing. Now that I have my y, the actual question starts now. What is the question? Is y increasing? Is y decreasing? Is y periodic? Let's see. Is y periodic? Do you think y is a periodic function? Do you think y is a periodic function? You can see y is a combination of cos function, sine function and exponential function. Exponential function is never periodic. So one part of my y is never periodic. That means my y itself can never be periodic. This is always wrong. Next, it says that y throughout is an increasing function or y throughout is a decreasing function. What do you think? Is y throughout an increasing function or a decreasing function? Let's calculate y dash. Let's calculate y dash. The constant part is same. 12 square plus pi by 12 whole square. This is to chalo undisturbed. Next comes 12 times minus sine pi x by 12. Minus sine pi x by 12 into pi by 12. Perfect. Plus pi by 12 cos pi x by 12 into pi by 12. Alright. Perfect. And minus, this is done. This is done. Minus, we have 12 e to the power minus 12x into minus 12. Perfect. Equal to 0. Why equal to 0? Because I want to compute the critical points, but it's very difficult for me to compute the critical points. Yes or no? It's very difficult for me to compute the critical points. That is so for sure. So what to do? What to do? It is increasing? Somebody is saying it's increasing. Somebody is saying it's increasing. Tell me, tell me, tell me. Huh? Quick. This to chalo gets cancelled out. E to the power 12x. Yes. Tell me, how to compute the critical points? How to compute the critical points? I can't just equate to 0 and compute the roots of this equation or zeros of this equation. I will have to somehow find out whether the sign of y dash is throughout non-negative. That would imply y is increasing, or it is throughout less than or equal to 0. That would imply y is decreasing. If the sign changes, that means the function is not throughout increasing, not throughout decreasing. Okay, it is increasing then decreasing or decreasing then increasing. Even if once I get the graph turning, even if about one point I get the sign of derivative changing, that means the graph is turning. There is a turn in the graph. It is not throughout increasing or throughout decreasing. Perfect. Got it? So just try to use some of the points and then compute the answer. Okay, when x is 0, what are you getting? Pi by 12 into pi by 12, it is positive, and there is plus 12 into 12, e to the power 0 is 1. Things are coming out to be positive. Y dash 0 is coming out to be positive. What about at 6? Let's say at 6. 6 pi by 12 means pi by 2, sine 90 is 1. 1 into pi, this is positive. Okay. And cos 90 is 0. Chalo, this is gone. And this is pi by 2 to the power minus 6. Oh. Obviously, y dash 6 is coming out to be negative. Can you see this? Yes, it is important. Don't feel it's not important. It is very much important. If I talk about y dash of minus 6, this will bachche come out to be positive. That means here is 0. Here is 0. Here somewhere is 6. Here somewhere is minus 6. Okay. The graph is increasing, then decreasing. That means before 0 it is increasing, after 0 it is decreasing. Somewhere though it is pakka changing. Its increase-decrease nature. Yes or no? 0 is not a critical point. At 0 also it's increasing. Maybe somewhere after 0 will be the turning point or the point of max. Yes or no? Because before it's increasing, and after that it's decreasing. But one thing is sure, throughout the real line it's not increasing, or throughout the real line it's not decreasing. That is why it is neither an increasing function throughout the real line, nor is it a decreasing function. There will exist some real number beta such that y equals beta intersects the curve at infinitely many points. This is true. What does this mean? Suppose you have a sine graph. It keeps on oscillating, no? So if suppose this is my beta, then y equal to beta line will keep on intersecting the graph at infinitely many points. Here. Why is this happening? Because the sine curve is increasing, decreasing, increasing, decreasing, increasing, decreasing, increasing, decreasing, increasing, decreasing. It's turning so many times that any line y equal to beta, for beta lying in the range of the function, will definitely intersect the curve at infinitely many points. But if my graph is continuously just increasing or continuously just decreasing, then any line would intersect it at exactly one point. It will be a 1-1 function. Okay, if it is strictly increasing throughout the domain or strictly decreasing throughout the domain, any horizontal line y equal to beta type of a line, where beta lies in the range of the function, will intersect it exactly once. Here, it's not an increasing graph, it's not a decreasing graph. That means it is increasing, somewhere decreasing, then increasing, then decreasing, then increasing, then decreasing, whatever. But line is intersecting it at infinitely many points. Is this cool? Is this cool? C is the right answer for this question, everyone. Are advanced questions necessary for mains? Time is very less. I'm starting PYQs of mains now. It's okay. It's okay. If you are attending these sessions, I have actually sat and collected the most important advanced questions, somewhat like what you can get in the paper. So these advanced questions which I basically bring, see, it's such old advanced questions. I have advanced questions of 2014, 16, 17, 20, 21, 22, 23, 24. All of them I'm bringing, but not all advanced questions. I'm very picky about the advanced questions which you must solve if you are going to attempt your JEE Main exam. After seeing the pattern of the paper, the analysis of it, and the NTA's mindset as well. So teaching for so many years actually gives us some experience to understand the mindset of the examiner, and based upon that I collect questions and bring in my sessions, which has benefited my students a lot in the past, and I'm sure it will benefit you as well. So from your side, if you are starting with mains PYQs, please focus on that, but do come and attend these sessions. Please be regular for these sessions, because here you will get a chance to solve those advanced questions which have high probability to land in the paper. Not exactly, but their tweaked versions or their similar patterns, because JEE loves repeating patterns. Okay, this is a homework question. After a long time, I'm giving you a homework question. I want you to solve this. This is a tricky question of 2021 JEE Advanced. This will require two cases. Please remember there are two cases you need to form. One is that alpha plus beta is 0, other is alpha plus beta is not 0. I have given you the hint. This is the only hint I will give here. Otherwise, the question is very simple. You have done more difficult questions than this. This will not seem difficult to you at all. If it would have seemed difficult, I would have solved it with you. Okay? Let's go to the next question now, because I have some beautiful questions left to be discussed with you. Very few questions, but very beautiful questions. One is this one. Take a look. I think I have solved a question like this in the Leibniz class as well. Newton-Leibniz theorems class. If f is a differentiable function in this interval such that f of a is 1, this is not a, this is 1. F of 1 is 1 and limit is 1 for each x positive, what is f of 3 by 2 equal to? Very nice question. JEE Advanced 2021. Anybody, any clue? Anybody, any clue? You tell me, Vijay, which chapter do you want? I am planning to come up with M&D, which is matrices and determinants. And don't worry, probability I will be putting as a recorded session on the channel itself. LH rule. Why LH rule? Limit t tends to x, t square f of x minus x square f of t upon t minus x. If you plug in t as x, please remember, here t is my variable. T tends to something. T is moving. T is varying. T is approaching. T is my variable. So plug in t as x, you will get 0 by 0 form. So apply LH rule on t. Okay, on t. F of x is like a constant. You will get 2t here minus x square as it is f dash t. Very important, people. This is where students commit the major mistake. Apply your LH rule on t. When you are differentiating, differentiate with respect to t. X is being treated as a constant, or any function of x is being treated as a constant. Whole upon t is 1 and then minus 0. 1 minus 0 is 1 only. This is limit t tends to x. Now if you apply the limit, you will get f of x into 2x minus x square into f dash x, and the value of this limit is given to be 1. What is this? Who will tell me? What is this? This is x square dy by dx minus f of x 2x equal to minus 1. If you take f of x as y, this will be y, 2xy, 2x into y. So you are getting x square dy by dx plus minus 2x into y equal to minus 1. Divide by x square. No. Divide by x square, divide by x square, divide by x square. You will get dy by dx plus minus 2 by xy equal to minus 1 by x square. What is this? Yes, you are absolutely correct. This is a linear differential equation. No, people. Yes or no? E to the power integration of minus 2 1 by x dx, which is e to the power minus 2 log x. X to the power minus 2 means 1 by x square. Minus 2 by x, no. Minus 2 by x, x to the power minus 2, 1 by x square. 1 by x square is your integrating factor. Is that clear? 2 is not the integrating factor. 2 is not the integrating factor. This is your integrating factor. So if I talk about the solution, what is it? Y into integrating factor is integration of q into integrating factor dx plus c. So y by x square is integration of minus of 1 upon x to the power 4 dx plus c. Yes or no? Is the integration clear? Now this is passing. F of 1 is 1. 1 comma 1 lies on the curve. 1 is equal to minus minus cancels out. 1 by 3 plus c. So c is 1 minus 1 by 3. 3 minus 1 is 2 by 3. Thank you. C is 2 by 3. Plug it back here. You will get y by x square is x to the power minus 3 upon 3 plus 2 by 3. What is f of 3 by 2? Huh? Can you calculate? It's very simple now. It's very simple. Y equal to x to the power 2 minus 3 is x to the power minus 1 upon 3 plus 2 by 3 x square. Okay, so y of 3 by 2, which means 1 upon 3. 1 upon 3 by 2 is 2 upon 3 plus 2 upon 3 into 9 upon 4. Okay? Okay, this is 2 upon 9 plus 18 upon 12. Okay, this is 36. 8 plus 54. 62 upon 36. 31 upon 18. Is this what you're getting? Are you getting 31 upon 18 as your answer? It's very simple, basic arithmetic. Towards the end, though, I have not done anything. I have not done anything at all. The only catch in this question was that you wanted to compute f, and for that, what are you doing? You're actually solving the limit. You're actually solving the limit using the LH rule. But when you are using the LH rule, what is happening? You're using the LH rule on t. You're differentiating with respect to t. And that is giving you a differential equation. So directly you don't have a differential equation in picture. But when you're applying your LH rule, solving the limit, equating it to 1, what you get as a result is a differential equation whose solution is the curve f, which once you have, then you are plugging in x as 3 by 2 and computing f of 3 by 2. Okay, is that cool? All the process, entire procedure, entire solution, is that cool? Yes? Alrighty, 31 by 18. Option D is the right answer. This is the last question for linear. And this is one of the most difficult questions on linear. This is a question where you are given a direct linear differential equation. That is true. dy by dx plus py equal to q. But the q function, which is f of x, actually is a split function. The q function is actually a split function. Can you see this? Your f of x is actually playing the role of q of x, which here is a split function or a piecewise defined function. This is the major problem. Your right hand side function f of x is a piecewise defined function. It is 1 when x is sandwiched between 0 and 1, and it is 0 otherwise. How do you solve a differential equation whose right hand side function is a split function or a piecewise defined function? It's a broken function. How do you go ahead and solve such a differential equation? Because by the look of it, it looks like dy by dx plus 2y equal to f of x. It's a proper linear differential equation. But how to go ahead and solve this? How? How to go ahead and solve this? Tell me. First steps first. Keep the basics clear. Because this is linear, I will directly compute the integrating factor. Now understand, I'm telling you the procedure. It's a very difficult category of question. Not many students know how to solve this. Understand very clearly in the first go in one shot itself. E to the power integration of 2 dx, which is e to the power 2x. That's the integrating factor. Done. What about the solution? What about the solution? It will look like y into integrating factor is integration of q into integrating factor dx plus c, and this is where the panga arrives. This is where the problem arises, because here I have f of x, which is a question. Why is this raising a question? Because I don't know which definition of f to use. In 0 to 1, I have f of x as 1. Beyond 0 to 1, I have 0. So here I am stuck because I can't integrate, no. In order to integrate, I should know something about f. But I don't know f exactly as one single defined function. I have two definitions of f. It's a split function. So what is the way out? The way out is look at what you need to find. You need to find y of 3 by 2. Now 3 by 2 is a greater than 1 quantity. So assume x to be greater than 1 and integrate from 0 to x. Did you get the trick? This is the trick. This is the trick, people. Please note it down. Because 3 by 2 is greater than 1, assume x to be greater than 1 and integrate from 0 to x. And integrate from 0 to x. Now, because x is greater than 1, your integral will break. Because x is greater than 1, your integral will break. You will get 0 to 1 plus 1 to x. Nice. You will get 0 to 1 plus 1 to x. So 0 to 1 f of x e to the power 2x dx. Here also f of x e to the power 2x dx. Did you understand? If suppose this quantity 3 by 2 would not have been greater than 1, I would have got, let's say, 0.5, which is less than 1. Then I would have assumed x to be less than 1. And integration from 0 to x. So if x is less than 1, that means x is lying between 0 and 1. So only one integral of f would have come in that case, not two integrals. And I would have used this definition that between 0 and 1, f of x is just 1. Here I am getting 2. Here I am getting 2. Very good, Priyanshu. In that case, only first integral would have come. Is that clear? Is the logic clear? Yes. Now between 0 and 1, it's 1. So I get 0 to 1 e to the power 2x dx plus 1 to x 0 dx. Yes or no? This is e to the power 2x upon 2 from 0 to 1. So this is 1 by 2 e to the power 2 minus 1. Is this clear? Yes or no? This is y into e to the power 2x. This is y into e to the power 2x. So y comes out to be equal to e square minus 1 upon 2 e to the power 2x. This is my y. I want to compute y of 3 by 2. So e square minus 1 upon 2 times e to the power 2 into 3 by 2. That's it. That's it. HDCC e square minus 1 upon 2e cube. E square minus 1 upon 2e cube. Is this clear? Guys, tell me, is this clear or not? Very important category. Not everybody knows how to solve this. Not every teacher comes and discusses this. This was asked in 2016 advanced paper, but you can see it's not a very lengthy question. If you actually see, it's not a very lengthy question. It's just a conceptual question. In a very small space, I was able to solve this. See, 1 page, 2 page. That too, I'm explaining, so I'm writing all the steps. If I have to do it in rough work, I can solve it in an even lesser space. So it's a very small question, simply conceptual question. That is why it's an advanced level question. But if I talk about the length is very small. It's not a very lengthy question, doesn't involve very heavy, irritating, frustrating calculations. No, it doesn't have very bad, non-good looking values also to deal with. No, it's a very pretty good looking, nice, small question, very much probable to land in your JEE Main exam, but only if you know the concept. Splitting the integral was the major part. Splitting this integral, this was actually the star mark part. This was the star mark part. When do you split? When do you not split? When x is greater than 1, you will split. When x is less than 1, you will not split. You will just take it from 0 to 1. Absolutely correct, because behavior is different in different intervals. Is this making sense, everybody? Can I take one more question and solve with you about linear. Will you be okay if I solve one more question of linear and then we move to exact? Just one more question. Very nice question. Tell me. See, linear is most important. After this, we have exact, which a lot of students struggle with. A lot of students struggle with exact. So I will be explaining you what is exact in a very simple manner. We will solve some questions and our grip upon exact will become very strong then. F is a function from 0, infinity to r, differentiable such that f dash is equal to 2 minus f of x upon x. F of 1 is not equal to 1. What about these four options? JEE Advanced 2016. Look at the question. It says f dash, which means dy by dx, equal to 2 minus y by x. So you can write this as dy by dx plus 1 by x times y equal to 2. Clearly linear differential equation, na bache? Clearly it's linear. So dy by dx plus py equal to q. This is your p of x. This is your q of x. Yes or no? So integrating factor will be e to the power integration of 1 by x dx, which is e to the power log x. So you simply get mod x. But mod x is equal to x since x belongs to open 0, infinity. You can see this, x is coming from here, the domain. That is why mod x is being resolved to just x. So integrating factor is x. What is my solution? Y into integrating factor is integration of q into integrating factor dx plus c. Very simple. So this is x square. 2 times x square by 2, 2 cancels out, x square plus c. Yes or no? So y into x is equal to x square plus c, but the problem is f of 1 is not equal to 1. This is y equal to x plus c by x. Very clearly and very honestly, this is my solution. But 1, 1 does not belong to this curve. Why? If 1, 1 belongs to this curve, 1 equal to 1 plus c. This implies c is 0. So if 1, 1 doesn't belong to this curve, 1, 1 does not belong to this curve, this implies c is not equal to 0. C is not allowed to be equal to 0. Guys, make sure you understand the meaning. C is not allowed to be equal to 0. That is what is being conveyed by the given piece of information, that f of 1 is not equal to 1. If at x equals 1, y is not equal to 1, that means c equal to 0 is not allowed. C equal to 0 is not allowed at all. Okay. Now what? Let's take a look at the options. Limit x tends to 0 from the positive, f dash 1 by x is 1. Is that true? Limit x tends to 0 from the positive, f dash 1 by x is 1. Is that true or not? Who will tell me? Who will tell me? See, you already have your f of x, na? This is your f of x. F of x is x minus c by x. If I ask you what is f dash x, you will tell me it is 1 minus c by x square. So limit x tends to 0 from the positive, f dash of 1 by x, is it coming out to be equal to 1? See, limit x tends to 0 from the positive, f dash of 1 by x. This is f dash x. What is f dash of 1 by x? 1 minus c upon 1 by x square. So 1 minus cx square. If x is approaching to 0 from the right hand side, x square is also approaching to 0. This will approach to 0. My answer will come out to be 1. That means option A is absolutely correct. Option A is absolutely correct. Multi-correct answer. Multi-correct question, bache. What is option B? Option B says limit x tends to 0, x into f of 1 by x. Limit x tends to 0, x into f of 1 by x. F of 1 by x or f dash of 1 by x? F of 1 by x. Okay, so this will give you limit x tends to 0, x into what is f of x? It is x minus c by x. So f of 1 by x will be 1 by x minus cx. 1 by x minus cx. This will give you limit x tends to 0 from the positive, 1 minus cx square. Again, this will tend to 0. Your answer will come out to be 1. Again 1. But here it says 2. So no, this is 1. No, this is 1. Third is x square into f dash x. Okay, you get the drill? This is wrong. x square into f dash x. F dash x is 1 minus c square, 1 minus c by x square, right? 1 minus c by x square. This will be limit x tends to 0 from the positive, x square minus c. This is coming out to be minus c. If x is tending to 0, your limit will come out to be minus c. But remember, c is not allowed to be equal to 0. That means minus c is also not 0. That means this limit is also not 0. Did you understand? It's minus c, you are right, but c is not allowed to be 0. So minus c is not 0. That means this c limit is also not 0. Yup. Mod of f of x is less than or equal to 2 for all x belonging to 0, 2. Is that true? Is that true? What is f of x? X minus c by x. C. X minus c by x. Is it less than or equal to 2 for all x belonging in, what was it? 0 to 2. Is that true? This is x plus. Plus. Okay, this is plus. Okay, x plus c by x is mod. Is it less than or equal to 2 for all x? Ved, if you take, be very careful. If you take x as 1, which lies in this interval, then mod of x plus 1 by x, we all know using the AMGM inequality, this is greater than or equal to 2. So this is not true that for all x in 0, 2, x plus c by x is equal to greater than or equal to 2. Yes or no? If you take c as 1, see if, let me write here, if c is 1, not x is 1, if c is 1 and x is anywhere between 0 and 2, let's say x is 1.5, if c is 1 and x is, let's say 1.5, then mod of x plus 1 by x will not be less than or equal to 2. So this is not true. In general also we know mod of x plus 1 by x is greater than or equal to 2 when x is non-negative. Right? So the moment you take c as 1, c is not allowed to be 0, but c can be anything apart from 0. If you take c as 1, mod of x plus 1 by x, we all know as a result is greater than or equal to 2 for all x non-negative or for all x positive, strictly positive. Right? That is why this D option is also not correct. C is also not correct. This seemed like a multi-correct, but it's actually a single correct. Seemed like a multi-correct, but it's actually a single correct. Is this okay, people? Is this okay? Is this question nicely understood? I have shared with you great variety of questions throughout this lecture till now. It's been 4 hours already. We have some portion left to be covered. So please brace yourself, have some water, munch something, and let's get started with the next type, which is, so this is correct, rest everything is wrong. Next and the last type, everybody, pay attention. Something which has very recently gained popularity. It's none other than exact differential equations or partial differential method, which is used to solve these equations. So let's start. In order to crack a differential equation using the exact form, certain results which you must remember, it's non-negotiable for you, are these. D of x plus y, dx plus dy, d of x minus y, dx minus dy, d of x square is 2x dx, you know already, d of y square 2y dy. This is also something very obvious. D of x square plus y square is 2x dx plus 2y dy. D of tan x is sec square x dx. Alright. D of x into y is x dy plus y dx. Very, very important. Remember, d of xy. This is first function differentiation of second plus second differentiation of first. You can remember it like this. You can remember it like this. But if I ask you x dy plus y dx is d of xy. If I ask you x dx plus y dy. What do you think is this equal to? Tell me. X dy plus y dx is d of xy, correct. But x dx plus y dy is what? This is half d of x square plus y square. See, d of x square 2x, d of y square 2y, 2 cancels out. Yes or no? Yes or no? Similarly, we have this. This is extremely important. D of x by y dx minus x dy upon y square. Very important, guys. First function upon second function differentiation of first minus first differentiation of second upon second whole square. This is how you can remember, very important. Similarly, d of y by x is what? Second function differentiation of first minus first differentiation of second upon second whole square. These two are extremely important. Similarly, you have this one and this one. Very easy to prove. Must remember. Majorly what you must remember is d of x square plus y square, dxy, right? And d of x by y, d of y by x. Suppose I give you a question. Suppose I give you, okay, x dy plus y dx upon 1 plus x square y square is equal to x dx plus y dy upon x square plus y square. Tell me. You wish to integrate. Okay. How to solve? Now see, x dy plus y dx is d of xy upon 1 plus xy whole square. Very easily integrable now. This is like 1 upon 1 plus x square dx, which is tan inverse x. That's it. That's it. Equal to x dx plus y dy is 1 by 2 d of x square plus y square upon x square plus y square. Guys, look at this. 1 upon t dt, log t. Log t, this is what? X square plus y square plus constant of integration. That's it. This is how you actually condense your expanded versions to smaller forms. Okay? Did you understand? This is how we exploit our exact differentials to solve questions. Formulas are the same. See, dt upon 1 plus t square. Did you see this left hand side? dt upon 1 plus t square is tan inverse t. dx or dt upon t is log t. The look of t is changing, rest everything is the same. So it's about the same eyes but a different lens. Eyes are the same, lens is different. Okay? Okay, this is where the result comes into picture. I've already told you. Now tell me, general solution of this differential equation is what's the JEE Main 2018 question? Please tell me. Tell me. This is x dy upon x square plus y square. Now the moment you see x dy, y dx, x dx, y dy, you know somewhere exact should strike your head. This is how you have to identify the question might be of exact differential form. So this is what you have. Then you have y upon x square plus y square dx minus dx. Oh. So let me do one thing. I have x dy minus y dx upon x square plus y square equal to minus dx. This much though is sorted. What next? What next? Remember this part? X dy plus y dx was d of xy. But x dy minus y dx upon x square. Second function, very good Vijay. Second function differentiation of first minus first differentiation of second upon second whole square. This is d of y by x. So to compress this bubble part, I have to divide by x square and multiply by x square. So what will I do? I already have x dy minus y dx. I will divide by x square. And at the bottom I have x square plus y square. Here also I am dividing by x square. It's the same, equal to minus dx. So this part completely becomes d of y by x. And what is this part becoming? 1 plus y by x whole square. Can you see that? 1 plus y by x whole square. So you have d of y by x upon 1 plus y by x whole square equal to minus dx. Very good. It's like variable separable. One is x, one is y by x. So till now we were doing variable separable like one is x, one is y, separated. But here one is x, one is y by x. One is x, one is y by x, separated. Perfect. What's the problem? So this is tan inverse y by x, yes or no? dt upon 1 plus t square tan inverse t equal to minus x plus c. That's your general solution. That's it. You just wanted to compute the general solution, not the particular solution. Okay, is this question clear? Let's go to the next one. See, again, x cos y by x, y dx plus x dy equal to y sin y by x, x dy minus y dx. Very important. Why is this so important? Because one thing which should strike your attention is, I have y by x here. If I divide by this x, I will get x here. Or rather, I will actually get x here. Yes or no? Again y by x here, again y by x here. So somehow it is reminding me that yes, you are correct, homogeneous differential equation. Because I can see my equation is possibly, it can be written in terms of y by x. It is somehow implying that this can be solved using the homogeneous differential equation method. This is homogeneous actually. This is homogeneous. In fact, you can try out how to solve this using the homogeneous method. So this question can be solved using the homogeneous differential equation method as well. Try it out, guys. Try it out. I will actually be solving it using the exact method. I personally feel that homogeneous is going to be lengthy. This is going to be shorter and smarter. And why exact is hitting my head? No. Why is it entering my head? Because I have y dx plus x dy. X dy minus y dx. All these expressions are famous in exact form. That is why it's striking my memory that, okay, let me use exact. No, let me use exact. Yes or no? So what will I get? I have x cos, okay, y by x. X dy plus y dx is dxy. This much is sorted. This much is sorted. What about the right hand side? Y sin y by x. This is x dy minus y dx. So x dy minus y dx, bache, if you want to compress this, you will have to divide by x square and multiply by x square. Correct? So this x and this x cancels out. Yes or no? I am left with cos y by x dxy is equal to y xy sin y by x. And this is what? D of y by x. Yes or no? Yes or no? So you have d of xy upon xy. Like together, I am separating the variable. I have sin of y by x upon cos of y by x, tan of y by x, d of y by x. Wow, man, wow. Look at this. Variable separable. One is xy, one is y by x. The look of the two variables now is different. One is x into y, one is y upon x. But you can see I have separated the variables. Now I can directly integrate. It's like 1 upon t dt, which is log t. So log xy equal to tan theta d theta. Quickly tell me, tan theta d theta, integration of tan theta is log sec. Yes or no? Log sec what? Y by x. Yes or no? You can write this as log c. Chalo, write this as log c. So xy equal to c times sec y by x. Okay? Did you understand? Yes, it is possible for you to, I guess it's possible for you to solve this using homogeneous only. Homogeneous also. Try it out as homework, but with exact things become super simple because easily you can see y dx plus x dy is directly compressible to dxy. And x dy minus y dx upon x square will directly compress to d of y by x. So very easily long expressions can be compressed to exact differentials. Alright. Hi, Laksh. Can I move to the next question, everybody? Everybody ready? Look at this one. Very nice question. JEE Main 2022. Here it's written slope of normal, people. Here it says slope of normal, not slope of tangent. Slope of normal at any point on this curve is given by this. You know, dy by dx at any point P is slope of tangent to the curve at point P. So slope of normal to the curve at point P will be its negative reciprocal, and the point itself is x comma y. So this is nothing but dy by dx. So its negative reciprocal will be minus dx by dy. This is given to you as x square upon xy minus x square y square minus 1. No. No matter normal is removed or not removed, everyone, you cannot afford to not study tangents and normals. You cannot afford to not study tangents and normals. It will be a big blunder, a big crime, a big mistake. Don't dive into too much typical questions on tangent normal. But if you miss the idea, if you don't know what is the actual concept, the fundamental idea behind tangent and normal, you can't sail through this exam, trust me. Tangent and normals is required in almost every chapter of calculus, especially calculus, and conic sections as well. So you can't sail through this exam smoothly if you are not aware of this idea. Okay? Is this cool? Yes or no? This minus sign I can adjust, no? Dx by dy equal to x square upon minus xy plus x square y square plus 1. Okay? Okay? Now, if I want to use my exact differential to solve this, I will have to cross multiply and separate the dx and the dy. Separate the dx and the dy. So, minus xy dx, okay, plus x square y square dx plus dx, 1 times dx equal to x square dy. Oh, what to do now? What to do now? Tell me. Tell me, no, what exactly can I see here is minus xy dx and here is a dx. Okay, so minus xy dx and this dx equal to x square dy minus x square y square dx. Okay, fine. So dx common 1 minus xy. Okay, and from here x square common dy minus y square dx. What is this? This is not anything. No, this is not anything. X dy y dx. Oh, if I take out xy common, tell me quickly, can I do anything? Can I do anything? Or rather, let me try and club something else. Let me try and club these two. So if I take dx common, 1 plus x square y square equal to x square dy plus xy dx. Now I can take out 1x common. I have x dy plus y dx. And this is dx 1 plus xy whole square. How is this beneficial? Now I have a smile on my face. Okay, equal to x and this is dxy. Wow, wow, so beautiful. This is what? Dx by x equal to dxy upon 1 plus xy square. Brilliant, yeah, brilliant. So nice. This is so nice. Like my heart feels so good. My heart literally feels so good. Yes or no? Dx by x gives you log x. And dt upon 1 plus t square gives you tan inverse t plus c. What is the doubt? What is the doubt? Quickly tell me what is the doubt. Okay, the curve passes through 1 comma 1. If the curve passes through 1 comma 1, 0, tan inverse 1 is pi by 4 plus c. So c comes out to be minus pi by 4. You get log x equal to tan inverse xy minus pi by 4. All righty. Perfecto. Perfecto. Now that I have this, what do you think? What do you think? What do I want? I want e times y of e. Okay, so let me do one thing. I'll write tan inverse xy is equal to log x plus pi by 4. Pakka. This is to pakka true. Now, e into y of e. So, tan inverse e into y of e is equal to log e, which is 1 plus pi by 4. So, e into y of e is tan of a plus b, which is tan a plus tan b upon 1 minus tan a tan b. 1 plus tan 1 upon 1 minus tan 1. 1 plus tan 1 upon 1 minus tan 1 is the value of e times y of e. This is your answer. 1 plus tan 1 upon 1 minus tan 1. Everybody tell me, is this clear? Is this clear? Yes or no? Very nice question talking about slope of normal. Then you separated dx, separated dy, and then the struggle came that where should I actually, which two should I actually club? So I clubbed these two and I clubbed this one and this one together on one side, and I was able to resolve it using the exact differential approach. Clear? Hashtag HDCC everyone. Let's go to the next question, which is this one. Oh. Let the solution curve of this differential equation pass through the point 1, 0 and 2 alpha, alpha, where alpha is positive. What is alpha equal to? Here again, I am able to see somehow that here there is y by x. Okay, let me use a different color. See, there is a y by x here, there is a y by x here. Somehow I feel even this can be solved using homogeneous differential equation approach. Somehow I am able to feel that this can be solved using homogeneous differential equation approach, because here there is x. If you divide by x, you will get 1 here, and divide by x, you will get y by x here. So I am able to feel, but this is your homework. This is your homework. I will be solving it not with homogeneous. I will be solving it using exact differential. Okay. Jwal, you can send your question in the Telegram group, which is study at @study with Bhoomika Ma'am, and I will help you out. Okay. All right. Let's go. X upon root over x square minus y square plus e to the power y by x, perfect, x into dy by dx. Okay. Equal to x plus x upon root over x square minus y square plus e to the power y by x times y. Okay? Okay, is that cool? What do you think will you do now? Because I am sending my dx to the other side, this will become equal to x dx plus this much dx. How will you resolve this now? Left hand side has whatever dy and right hand side has something dx. Tell me. Tell me. See, here I have x upon under root this. Here also I have x upon under root this. Can I somehow bring like things together? See, on the right hand side I have x dx plus x and then y dx upon root over x square minus y square plus e to the power y by x y dx. Correct? And left hand side has this much part. Okay. What should I do? Think. Please think, no? Left hand side, if you resolve, you will get x square upon root over x square minus y square dy. Okay, x into e to the power y by x again dy. So why don't you do one thing? This part you bring here and this part you take there. You will get x square dy minus xy dx. Okay, right. X square dy minus xy dx upon root over x square minus y square. Correct? Equal to x dx. Perfect. Minus x. Let me write it here. Equal to x dx minus x into e to the power y by x dy, alrighty, plus y into e to the power y by x dx. Okay, fine, cool. From here I can take out an x common. I'll be left with x dy minus y dx. Okay, fine. X dy minus y dx. Alrighty, this is x dx as it is. E to the power y by x common. I am left with what? X dy minus y dx. Same thing. Tell me. Tell me no. If I divide now by x square, will that work? If I divide by x square, will that work? Quickly tell me guys. If I divide by x square, will that work? It has to work because x dy minus y dx upon x square is nothing but d of y by x. Yes, very good. Very good. That also we can do 100%. I can cancel it out in the first go itself. So if I divide by x square on the left hand side, divide by x square on the right hand side, divide by x square, and this also divide by x square. You understand, right? X into d of y by x upon under root x square minus y square equal to 1 upon x dx minus e to the power y by x d of y by x. Tell me, this I can write as x square common 1 minus y by x whole square, and under root x square is nothing but x. So I am getting what? X root over 1 minus y by x whole square. This x cancels out. This is how I am making everything compressible. Is this understood? So d of y by x upon root over 1 minus y by x whole square. Is this clear? Yeah, you can do that. Same, I am telling you, you have to solve it using homogeneous as your homework, which you are doing it right now in the comments I can see. I am doing it using exact. Okay, equal to 1 by x dx. Then I have minus e to the power y by x d of y by x. Integrate. What is dt upon root over 1 minus t square? Tell me. Yes, sine inverse t. So sine inverse y by x equal to log x minus e to the power y by x plus c. That's it. That is it. Now because 1, 0 is lying on the curve. When x is 1, y is 0, sine inverse 0, 0, log 1, 0, e to the power 0, 1 by 0 by 1. This is 1 plus c. C is 1. Are you getting c as 1? Yes, you are correct. You are correct. So you are getting sine inverse y by x equal to log x minus e to the power y by x plus 1. 2 alpha comma alpha also lies on this curve. 2 alpha comma alpha, sine inverse 2 alpha comma alpha 1 by 2 equal to log 2 alpha minus e to the power what? Tell me. Alpha upon 2 alpha, again 1 by 2 plus 1. What is sine inverse half? 30 degrees. So pi by 6 equal to log 2 alpha minus root e plus 1. What is alpha? Huh? Tell me. See, here you have pi by 6 plus root e minus 1 equal to log 2 alpha. So 2 alpha becomes equal to e to the power pi by 6 plus root e minus 1. So upon 2. Upon 2. That's it. Can you see this? It's upon 2. Cool. This is alpha. So this much part was still okay. Like when you have the curve, you can plug in the initial value condition, get the value of c. Once you have your c, you plug in x and y as alpha comma 2 alpha or 2 alpha comma alpha. Solve for alpha. This much part is very arithmetic. What is the magical part if I use exact is how I am clubbing the terms together and how I am able to connect that okay, x dy minus y dx is reminding me of this result. How am I clubbing things together and compressing them using exact differentials? That is the magic which you have to capture. That is the major takeaway for you. Okay. And of course, if you solve it using homogeneous, perfect, great job done. I'm not saying that's a wrong approach. I am just saying that you must know how to apply exact, and that is what we are doing through these questions. What about this question? 2y e to the power x by y square dx plus y square minus 4x e to the power x by y square dy is 0. Now here it's written x of 1 is 0. What is x of e? That means when y is 1, x is 0. Ulta. When y is 1, x is 0. What will you do? What will you do? This is a little difficult question. Not denying, being very straightforward with you, little difficult question. Let's open it up. Let's open it up completely. 2y e to the power x by y square dx plus y square dy minus 4x e to the power x by y square dy equal to 0. What do you think I should club? What do you think I should club? Tell me. Here also you will rack your brain, na? You can see this and this have the exponential term common. So e to the power x by y square, in fact 2 times common, y dx minus 2x dy. Oh my god, what is this? Wait a second. Y dx minus 2x dy. That too I have done. Y dx minus 2x dy. Can you compress it? Why? When I wrote y dx, I was thinking minus x dy will come. But minus 2x dy is coming. What is this? Is this compressible? Can you compress this? This is the difficult part. Can you compress this? What is d of x by y square? Tell me. Second function, differentiation of first minus first into differentiation of second upon y to the power 4. Or you tell me one thing, instead of x by y square, y by x square. Yes. Yes, Harry Potter, x square dy minus 2xy dx, because it's first function, which is y into 2x dx upon, is it what you have? No. No, this is not what you have, y by x square. Ved, I don't have it. What if I again write x by y square only? Second function differentiation of first minus first differentiation of second. So 2xy dy upon y to the power 4. Now carefully observe this. If I take 1y common from the numerator, I will get y dx minus 2x dy. Cancel out, you get y cube. Yes, correct. Did you understand? This is not going to come here. We are going to use this. d of x by y square. 1y cancels out from the numerator and denominator. So what is this equal to? What is this equal to? 2 times e to the power x by y square, and this is y cube times d of x by y square. Yes or no? The numerator is y cube times d of x by y square. Okay? Plus y square dy. Yes or no? Bas, we are about to get done, Ved. About to get done. About to get done. Please tell me, is this clear? Is this clear? Okay. If I divide now by y cube throughout, y cube, to get rid of this y cube, this gets cancelled out. This I'm left with 1y below. So I have 2e to the power x by y square, d of x by y square, alright, equal to or plus 1 by y dy equal to 0. Yes? Okay. Perfect. Then integrate. This is 2 times e to the power x by y square as it is, plus log y plus c. Difficult लगता है, Ved. That is why calculus also holds the highest weightage. Largest share in the paper is calculus's weightage. Lion's share. And that is why attend these sessions. Please solve these questions. I am taking so much of effort standing here and teaching you for so long. You can at least be interactive and solve these questions with me. These are questions which are a must do, guys. I'm not joking. I'm not kidding. That is why I'm standing here, not giving you homework. These questions I'm not giving you as homework. I'm actually standing and solving them. Not sitting and solving, standing and solving them. So you please don't be lazy. Please don't act like you're tired. You're not. It's all in the head. It's all in the mind. Okay? Is this cool? Now when x of 1 is 0 means when y is 1, x is 0. When y is 1, x is 0. So this is 2 into 1. Y is 1, x is 0. So c is equal to 2. Plug it back. You get 2e to the power x by y square plus log y equal to 2. Yes? What is x of e? That means when y is e, what is x? So 2 times e to the power when this is upon e square plus log e is 1. This is 1 by 2. So x upon e square is log half. So x is e square log half, which is 2 to the power minus 1. So minus e square log 2. Minus e square log 2. Did you see the journey? Did you see the journey? Try it out. See, every question which I'm doing with exact mostly can be done with homogeneous, but exact just gives you a shorter, a smarter way to reach to the answer faster. Nothing else. Just reach to the answer faster. Nothing else. Is that okay? Very good, Ved. Very, very good. Minus e square log 2 is x of e. Minus e square log 2. Now, this is a question which I will not complete for you, but the start of it is very difficult. It's a typical question. It's a teda sawal. It's a tweaked question which will require some brainstorming in a different direction. So everybody, please pay attention. X minus y square dx plus y times 5x plus y square dy equal to 0. Looks like very easy. I want to just compute the general solution. I have x minus y square dx plus y times 5x plus y square dy equal to 0. Looks very easy, but not very easy, trust me. And that is why I want you to pay full attention here. Different type of an exact differential equation, and it will actually lay before you a different method altogether. So see, open this up. x dx minus y square dx plus 5xy dy plus y cube dy equal to 0. Try to club things which can kind of give you an exact differential compressible form. Try to. Tell me. At max, we can try to compress this much part. See, minus y square dx plus 5xy dy. I can take out y common. I have 5x dy minus y dx. Oh. Problem. X dy minus y dx, I know. I can divide by x square, it will be d of y by x. But this 5 is creating a big problem. Somehow I'm very close to my exact differential, which is d of y by x. But right now I can't directly write it. Why can't I write it? Because I have this 5 acting like a big problem, no? This 5 is acting like a big problem, no? Yes or no? I'm reading your chats consistently. Tell me. If 5 would not have been there, then x dy minus y dx, I know how to compress into an exact differential of d of y by x divided by x square. That's it. But this 5 is creating a problem, no? So yes, looks like this can be solved using exact differential approach, but right now it is not in the standard format of an exact differential equation. And that is why right now I can't do anything. I have to reduce it to exact differential equation. That's the catch. Just like you had reducible to variable separable, reducible to homogeneous, reducible to linear that we call Bernoulli, similarly some equations are very close to being exact or being exact differential of something, but like very close but not equal to. Those are actually reducible to exact. So here I would need some substitution which can help me reduce this equation to exact differential. Can you tell me what is the substitution? You can take 5 common forcefully, but that also will not help you, na? That will also not help you. See, if you try to simplify this, you will get y dy equal to y square minus x upon 5x plus y square. And this is dx. Tell me y dy, this is minus of, yes, I guess this is correct. I have deliberately written it in the form of dy by dx. Dy by dx. Now I will use a substitution. Let me take y square equal to t. This is the tricky substitution part in a differential equation. So now you get 2y dy by dx is equal to dt. So y dy by dx is dt by 2. So you get dt by 2 is equal to y square is t and 5x plus t. Here you can see, no, y square everywhere, and here also there is y dy by dx. Very much this was giving me a hint to take y square as t. So that y dy by dx can become dt by 2, obviously, and that's it. Now I will ask you to cross multiply. Should I? No, I will not ask you to cross multiply because this is a homogeneous differential equation, bache. This is a homogeneous differential equation. Can you now solve this by yourself? This is a homogeneous differential equation. If you wish to, you can change t with y. You will get dy this much dx. You can bring it here. Dy by dx is dt by dx upon 2. So this is dx. I missed dx. You can write dy by dx equal to 2 times y minus x upon 5x plus y. This is a homogeneous differential equation. Yup, you are right, Ved. So this was not exactly reducible to exact, but looked like exact and got reducible to homogeneous. But this is reducible. This is a reducible differential equation. It is not right now in any standard format. It's not variable separable. It's not homogeneous. It's not linear. It's not exact. So equations like these also can come in the paper, which are actually fitting into no format. None of the formats they are fitting into, but you can again perform a substitution to reduce them into something. No, Nina, I did not put something. I'm just saying you are more familiar with dy by dx. Right now you have an equation involving dt by dx. So if you are uncomfortable with t and y are just dummy variables. So in place of t, you can plug in y. That will make the situation more favorable to you. Now it's homogeneous. You know, you can take y equal to vx. So dy by dx equals v plus x into dv by dx. Okay? Then so you know how to solve, I think. You will use your partial fraction method to further integrate. Can you do that? But t equals y square. Okay. That is how you are looking at it. Then I feel don't take. I get your point. Don't take. Is this clear? Take t equal to vx. So dt by dx equal to v plus x into dv by dx. Is that cool? Is this much cool? Is this much cool? Ved, Nina, please answer. Okay, so I have dt by dx equal to 2t minus 2x upon 5x plus t. Okay, dt by dx is what? V plus x into dv by dx. T is what? Vx. So 2vx minus 2x upon 5x plus vx. So x cancels out. You get 2v minus 2 upon 5 plus v. So x dv by dx is equal to 2v minus 2 upon 5 plus v minus v. This will give you 2v minus 2 minus 5v minus v square upon 5 plus v. Solve this. This is minus v square minus 3v minus 2 upon 5 plus v. Minus common, v square plus 3v plus 2 is x dv by dx. Almost done because here it says dv upon v square plus 3v plus 2. Okay. Equal to dx. Acha, this is 5 plus v. 5 plus v dv. Perfect. Dx upon x minus dx upon x. Integrate. How will you integrate the left hand side? Right hand side to is sorted, minus log x plus c. How will you integrate the left hand side? Look at the denominator. Look at the denominator. Can you not write it as v plus 1 into v plus 2? The moment your denominator looks like product of two linear factors, what is it? See, 5 plus v upon v plus 1 into v plus 2 is equal to a upon v plus 1, b upon v plus 2. Plug in v as minus 1. Plug in v as minus 1, 5 minus 1, 4, 4 upon 2 minus 1, 1, 4. Is a coming out to be 4? Huh? Shortcut you remember? One of the zeros is minus 1. V plus 1 equals 0 means v is minus 1. Check out this factor. Plug in v as minus 1 in this much part. You get a equal to 4. Similarly, do for the next as well. What is the 0 here? Minus 2. Check out this part. In this much part, plug in v as minus 2. You will get 3 upon minus 1. So, b is minus 3. 5 minus 2 is 3. 3 upon minus 1, b is this. This is how you use the shortcut. Shortcut for partial fractions. Shortcut for partial fractions. Is that cool? Very good. Very good. So what are you getting? Integral. Tell me 4 upon v plus 1 minus 3 upon v plus 2 dv. equal to minus log x plus c. You can solve this now, right? Yeah, LCM, you can take LCM and compare. That is the traditional method only. But I am just saying, for the shortcut method which you can use to save your time, do this. Okay? Now I guess you can very easily solve and get your answer. Very good. Very, 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 very good. On this note, we have come to an end of our lecture. It's almost 12. Almost 12. Yeah, this method is better because it's a shortcut. This is your homework question, bache. This is your homework question. Now you have to decode whether it is of variable separable type or reducible to variable separable, or is it homogeneous, reducible to homogeneous, linear, reducible to linear, exact, or not any of these four and reducible to any of these four. That is something for you to discuss. I am not going to reveal that. On this note, it's me, Bhoomika, signing off. I want all of y'all, before you leave the class, hit the like button. And if you enjoyed today's class, wherein I shared with you questions from every direction, every parameter, every possible approach, I will be coming up with top 10 or top 20 questions of differential equations again, because the bank of questions which I have is supremely huge. And of course, you always need to practice as much as you can. Okay? Yes, mixture of all. This chapter's one shot was what was discussed today, and that is what I have given full justice to. Not even one aspect of this chapter has been left. Every type of question, variety of question I have tried to cover in this session. Yes, it was a little long session, but it's okay, it's worth it. If you have stuck throughout the video right till the end, if you're staying till the end as well, that means you have solved all the questions with me. Please note, bache, please note all the questions wherever you've solved. Make sure that the results or the concept which is being used to crack that question, you are separately writing it on the right hand side and making a dabba around it, make a box around it. Any trick or any specific substitution which is being used, any out of the box approach if it is being used, write it separately inside a box to the right of the question. So towards the left, if you're solving, right side if there's space left, with a different colored pen, write the approach, write the trick, write the shortcut, write the out of the box idea, okay, which is involved to crack the question. If there is a certain type of question which you were not able to understand in the first go, and you feel it was very difficult for you to comprehend, even when you understood, you were like, oh, I have not solved such a question, I have to come back to it multiple times to cement it in my memory, in my system, then make stars around it. Highlight that question using the highlighter, so that when towards the end you are flipping through the pages while revising, all these things which are inside the dabbas, inside boxes, which are highlighted, which are star marked, they enter the photographic memory of your head. That is a very, very, very crucial tool for revision. Very crucial tool for revision. It's like a cheat code. Last minute revision tools, last minute revision hacks are these hacks. Because you have done your hard work of solving the question. It's just that some highlights of those questions you want to again reiterate in your memory and head. And that you are able to do when you have marked all of this while you are solving. Okay? Also, if there were any questions where you were stuck, you were not able to solve in the first go, please revisit them, resolve them. Again, spend time with them. And still, if there is any doubt, let me know in the comments below. Also, don't forget, this is my Telegram group. Please join it ASAP. If there's any doubt again, let me know in the comment section or on the Telegram group. Yes, Vijay, don't worry and keep yourself subscribed to the Rankplus JEE English channel, because either in the live session or in the recorded video format, I keep pushing out many questions, tricks and shortcuts which are going to be beneficial for you, supremely beneficial for you in this short span of time which is left before your first attempt of JEE Main. All right? Yup. Yeah, okay? Alrighty, thank you so much. It's me, Bhoomika, signing off on this note. Please take care of yourself. I know it's too late. Go and take a good sleep. Good night. Sweet dreams. See you tomorrow. And may you dream, in your dream, may you visualize yourself to have cracked the JEE exam and you're sitting in your dream college with the best subject, best course possible, best of your friends around you, having fun in your top best college. All right. All the very best. Have sweet dreams and visualize whatever you want to achieve in future, wherever you want to reach in future. Okay? Good night, everybody. Next class you will get to know very soon on the channel itself. We upload the schedule in the community section. But my next class most probably will happen on Saturday. That is going to be a live class. Before that, I will be pushing out a lot of recorded videos on the channel. So make sure you subscribe. Make sure you keep checking what has been uploaded as well. Okay? Thank you so much. Bye-bye. Take care.